Good morning. Welcome. We welcome you all, and also those who are listening to us virtually at the 18th International Wood Architecture Conference. My name is Andrus Kõresaar. I am Veronika Valksiska. Wood is the hero of our conference. It doesn't need an introduction. We all have a warm relationship with wood, timber, a lifetime relationship, because we are encountered with wood throughout our life, from our youth. When I look at my little boy who's crawling around the wooden floor of our home. Wood and love, we all have this love for timber, and some of us may flirt with wood, but for many of us it's a lifelong relationship with wood. Fortunately, it is a two-sided relationship. Wood doesn't declare its love, but it shows its love in its nature. It's pleasant, even soft, but it also is something that's constant. It's our one-legged friend, because as humans, we don't often, have a very friendly relationship with wood sometimes. When you look out of the windows today, previously, when we've had our conferences, we've never had such warm weather in November in Tallinn. And when we discussed it with the engineers this morning, it also creates a difference into the life circles of wood, because the life circle is sort of wider in the tree. But before we continue with our first welcoming words to our guests and visitors, I would like to remind you that we have interpretation that is provided. Please help yourself to headphones.
In case you didn't notice, we have the headphones for translation that you can get at the front desk. So if you'd like, just as a reminder.
But I would like to give the honor, and I'm really glad to welcome on stage our Minister of Climate, Yoko Alender.
Tere hommikust.
Good morning to everybody. I'm very happy to be here, and it's not the first time. But, I'm always with you, with my thoughts, and I think that we think in the same direction, because as my background, I'm also an architect, and as a matter of fact, right now, I am also the climate minister of Estonia, which means that probably I can make a little input into all this. We are living at the time when we all understand that our resources are limited, and the climate crisis means that we have to change our habits, and architects definitely have their own role here, how we can decrease our CO2 footprint and use our resources more wisely. Wood is something that connects people and nature, innovation and tradition. How we use the material is our responsibility. We have that responsibility in front of the coming generations, and we can't be too dependent on fossil fuels. And that's why wood is even more important. We have to cherish it as a renewable material. And that helps us to decrease the CO2 waste. As a climate minister, it is my task to ensure that managing forest is sustainable. Forests, they provide us valuable timber, but we shouldn't forget that taking care of the forest is our responsibility, all of us. And we understand that the demand for renewable materials is growing in every sector. We are in the point where we don't need wood only for construction, but also for textile, road construction. I think we can prolong the list quite a lot by now. Whatever innovation topic we touch, wood is there. And that means that there are also bigger requirements for the stakeholders in the sector. We have to use wood in a responsible way and also understand the life cycle of it. In the work plan of the government, we have also pointed out that in using our natural resource, we have to proceed from the principles of circular economy. And the putting more added value to these materials is the key word here. We'd like to be the example for everybody, and we'd like to use wood in public building, and that would be an example for others as well. And if you look around in this building, which is the cruise terminal, also the state had its own input, and you see that quite a lot of wood has been used here as well. So Tallinna Sadam, the Tallinn port, is also helping us in this case. There is another good example. It's the nature house, which is under construction right now, also near the port in Noblessner. And this is a unique possibility for all of us to introduce our innovation and the use of wood as a material to the rest of the world. And I am quite sure that it is going to be a reference building in the future for its unique solutions. There are all sorts of solutions which have been worked out, which can be used also in the future for building office buildings, but also residential housing. And coming back to the keyword sustainability, so sometimes we have to think also what happens to the material when it reaches its end of life period. And the expectations of the society are ever increasing, so it's not just other materials, but even wood. It is possible to reuse wood also after its first use, and this is something that guarantees this precious material long life cycle. We shouldn't speak about construction or building as a technical process, but also taking architecture as part of our social responsibility task. And we need transparency here. Transparency, how we use the material, but you can actually get the feedback only on something you can measure or benchmarking. And that means that we need science-proved evidence for the use of materials in the construction sector. And this is where we can prove that wood as an architect has a great potential, both for architects, but also for constructors, builders, and it's a big challenge, but it's also an opportunity. It's an opportunity for us to prove that wood is the best possible in a certain situation. I think that today's conference and the know-how we are going to share, that gives everybody some food for thought, how and to what extent can we help the sustainable development in Estonia, how we can develop the spatial development in Estonia, so that innovation and sustainability would be a natural part of our work. And the final words, for some reason, I thought about a visit I once made to the piano factory in Estonia. I don't know how many of you have had a chance to visit that wonderful place. It is in Kalamaja, a suburb of Estonia, and it's a company which has a very long tradition. A lot of work is still manual there, and they rely on traditions. What they are doing there is something that is inspiring all of us. So what could architecture from wood be like? As we know, most of the pianos produced here, they go for exports, but this is the connection: wood, music, singing, something smooth, beautiful. And I think we can all think big today. We can inspire each other, and I wish you luck, and I wish you a good conference. Thank you for the organizers who never tire to organize it. Thank you.
Thank you, Minister, for these welcoming words. We would just like to let you know that you can ask the presenters questions. You can do it online, and obviously here in the auditorium we have microphones that will pass around the room. In case you are watching us online and you'd like to ask questions, we have the workshop environment with a link, and the QR code is also visible on the screen. So please go to the questions and answers section and you can type in your question. So we will be asking the questions that you have posted from the presenters. And when you first enter the workshop environment, you have to type in your email, please. We would also like to point out that during the breaks in the next door room, we have the exhibitors and also the Wood Award nominees. At 5 p.m. today, we will have then the Estonian Wood Architecture Award ceremony. The gala will start at 5 p.m. And after the gala, or the award ceremony, please don't rush home because we have a gala dinner. You can discuss what you heard today with colleagues. And we would also like to use the opportunity to thank our sponsor, Rahvusvaheline, who designed the stage. And we wish them all the best in their business. Our first speakers are our engineers, Jürgen Einpaul and Karli Nurk. Their presentations indicate that innovation happens amongst us. We will learn how large timber constructions can be hung up as if, you don't even notice. Jürgen works at the engineering office Est Consult. He also teaches at TalTech University and the Estonian Academy of Arts. He has a master's degree from TalTech and a PhD in structural engineering from EPFL in Switzerland. And he will tell us about the structural engineering challenges of the Pelgulinna Upper Secondary School. Karli Nurk is also a master's degree owner, and for the last 8 years he has focused on the structural design of timber structures. And his topic also will be focusing on the PERG, the Pelgulinna Upper Secondary School, and the findings for the best solution. So Jürgen and Karli, the floor is yours.
Tere hommikust ka minu poolt.
Good morning. I'm Jürgen Einpaul from Est Consult. And the way we've divided is that our program today will at first focus on the boring technical parts, and then we'll have the more exciting architectural designs. But yes, together with Karli, we joined the design stage in the latest of the stage during the operational design stage. So the procurement had already been made, the construction company had been chosen, and the architectural design had already been completed. So we were there for the finest details, finest tuning, so to say. So Ott Talver, who's one of the architects who designed the school building, he will focus on the building generally, but I will go into details. Most of you, I hope, here are familiar with the building of Berg, the Pelgulinna Upper Secondary School. If not, then you'll at least get the idea of the integral whole, despite the fact that maybe, we are starting not in a very logical manner because I'm focusing on the details. But as an engineer, what is exciting for us, or what was exciting for us in relation to this building, was then the anything to do with the foundations and then this frame facade, the truss facade. So I'll focus on these two parts. If you have any other questions, then please don't hesitate to ask. I don't know if I'll be able to answer, but I'll try. So maybe we can come up with an answer together. And Karli will then take the floor after me, and he will then talk about this wooden frame solution, because that's how we divided our work. Est-Consult, my company, we dealt with the general things, the concrete structural parts, and Makespace, where Karli works, they focused on the wood and CLT and glulam solutions to do with the structural designing of the building. So what was difficult with the foundation of the building is that the ground that the house is built on is very complicated. So it's in the northern part of Tallinn. It has sandy soil. It's kind of like a beach area, has pine trees, but the soil is clay 4 to 7 meters deep, and that's why when the building was designed, it had to have wedge piles. So these wedge piles, 600 millimeter wide piles, and they reached the depth of 7-8 meters from the ground level. So that's where the soft part sort of finished. So, and the principal design also indicated that we should consider using wedge piles. Wedge piles are a specific technology that a company in Estonia has developed. So these wedge piles, they are up to 3 meters long, sort of like they have a wedge at the end, and then they are drilled into the ground. And because of this, they sort of tighten the soil around. So with these wedge piles, we get a very strong and stable foundation for the building, for the structure. But their effect isn't deeper than their length of the pile. So if we can tighten this sandy part, then the clay part problem still persists. So it could cause settlements. So the characteristic of the building, if you know the building, well, remember this, the building has 3 parts, and all of the parts are at different heights, which also means that they have different weights. They weigh differently. And most of the building is wood. It's timber, but some parts are concrete, like the highest part of the highest block. The central part has some conference auditorium parts, and the spans and the loads there are very high. So if you build this structure on a very soft soil, it means that it's going to settle at different levels. So if it was just one building, then it would be different. So, as it's at different heights, then we had to consider this, because the different parts of the building would sort of sink at different levels. So this is something that we had to consider. And as the builder had to simplify the foundation, which again meant that it would cost less, then we analyzed how could we optimize the foundation of the building. So with Est-Consult, we had a 2D model, and Kurmik, the other company, they made a 3D model. So the highest part of the building, which has the concrete part, that the settlement would be about 10 centimeter and the outer walls about 2 to 3 centimeters. So structurally, it's a relatively simple building, wooden slabs and beams, but obviously you can't have, the floor being raised inside a room. So when doing this 3 and 2D analysis, then we discovered that partly we could use those wedge piles. So the final solution was that we created a hybrid system for the foundation. So the lighter part that weighed less, the lowest part, that's the gym, which mostly is empty. The load is lower. So that's on wedge piles. So the picture on the right-hand side shows you the operational design solution, and the lighter part then is on wedge piles, and the heavier part of the building, we replaced those 600-meter piles with steel ones. And then the middle part, we sort of created a situation where the load is sort of a grid where the load is divided. So if one part would settle more, then we can, transfer the load onto those steel piles and balance it, so to say. And it seemed as if it has worked. So there have been no problems with settlements of the building. And the reason why I'm talking about the foundation, this is for you architects. You perhaps, Tershagi, who knows about foundations, who says that there's no glory in foundations. The only person who thinks about the foundation is the one who knows that something might go wrong with the foundation. But when you look at the design of the building, so you can't see the soil, the ground at all. You can see that a lot of the foundation is in the ground there. And if we talk about reducing the footprint, saving materials, it's not the visible material that we see on the ground where we can make a difference or make things better and be wiser, be smarter. Foundations and saving on foundations, you can do a lot. You can even save more than on the bit that's on the ground. So it all has to do with the planning and the designing. So if we have an objective to reduce the footprint, then don't forget that the bit that we don't visibly see is also important. And the other part that is intriguing to most of us, or that seems complicated, it is then this timber truss frame facade. So what will the architect of the building will tell us about what they try to express with it architecturally, but for us it's partly shading, and it was also an interesting challenge. So when you see this structure, then the first question that we had, it's such an unstandard structure, so you don't get a direct answer. How do you design, or how do you calculate the loads? So the wind pressure, the wind load calculation, we had 3 different engineers who offered 3 different solutions. So the principal design solutions looked at it as if a rough surface, and then there's a standard depending on the surface of the building. How do you calculate the coefficient of friction? So this is tin that's on the roof, for example. But then you have the coefficient of friction and 0.04 kilonewtons per square meter. Then the second approach, which was the construction company's engineer consultant who had recently had to solve another site issue which had a similar facade. So some facade elements started becoming unattached. So we should look at every single truss as a separate element. So, and then this calculated area subject to wind friction was actually a lot higher, as you can see, 0.25 kilonewtons. And the third version that we actually used was that we looked at this friction on each of those trusses. So if one, as they are, crisscrossing one another, then the one that is in front gets more of the friction than the ones that are behind it. So this was the final calculation. So these are sort of things that don't fall within the standard. You have to look outside the box, and you can have different approaches, and obviously these approaches give you different results. And the first answer that you get may not always be the correct answer. And the second issue to do with the facade had to do with the ice accretion. So this icing load can be a problem with such timber frames, but the standard again doesn't feature it. So there is the new Euro Codex for the ice accretion calculation. So it depends on the climate of the area and the load classes. So the ICG G1 to G5. So we don't quite know which class Estonia falls into. I sort of presumed or came to the conclusion, so I deducted that we are in G2. The ICG is 2, which means that the ice accretion could be 2 centimeters. I talked to a former colleague who also had a similar issue and also came to the same conclusion that the Estonia ICG class is G2. So we came to the more or less same opinion. So ice load is another thing that we've considered. So there's been a question, can you climb up this frame to the top of the building? So how high can students climb depending on their weight? So, so the wind and ice, they are heavy enough that, we don't really think about the facade being crawling with students. So when you look at the facade, then we have to guarantee that the intersections of the facade elements are rigid. So in the standard, you had this element that you see on the left-hand side. I looked at it and I thought that, okay, that we could use it. So we actually included it in the project and realized that we need 30,000 of these particular elements. There are 3 producers that have them in their catalogs, those elements. But then after a number of telephone calls, I realized that in Europe, they've only made 3,000. And that they've been made like 20 years ago, and there are no machines that actually make them anymore, and that they're actually trying to get rid of the machines that made these elements. But in the standard, it is included. So unfortunately, for practical reasons, they are not really used very widely. So we could not use it. So that's why the intersection was done with wood screws, and that they can carry the load. And then the other topic that came up was that those trusses, they've been designed as very long bits, but they were up to 6 meters long, these elements. So we had to, obviously, join them together. And that is why for the facade, I think it was, 20,000 meters that we used of wood. So we had tests done with only a few meters. So we tested this joint. So how tight can we make this connection with the screw? And our result was that there was a sort of a particular bending moment. So in the front of the building, you can see that there is a 7-meter glass facade, and they are vertical, those trusses, and as the regular joint, we had to make a special solution where we made the joints that there is a sort of a steel pipe that is tightened with epoxy glue. And then there are self-tapping screws. So these had, again, this special solution that we had to come up with. So in the higher parts of the building, the frames are quite thin, those trusses, and then we had to hang it from the roof. So we had to hang it. So we also have sort of stainless steel elements that we've hidden. So it's like this steel pipe that you can see, and this helps again to sort of hang the facade on the building. And the lower part of the building that doesn't have such long trusses, so stability is not an issue there. So that's where we don't have any of those diagonal trusses. And then on each floor, we also have tiny little horizontal parts that help with the wind load, because the joints are not very rigid in between. So again, we had to think of how we place them so that we actually have a stable system, where you can see on the right-hand side there. So we had to have those additional support elements on the facade. This is what they looked like, these additional bits that we installed to hold the facade. So it was important for the architects that it's 16 millimeter diameter. Perhaps we could optimize it at 12 millimeters. So if you, I know that our foreign visitors, foreign guests will be taken on a tour of the building, then do and find those diagonal parts. This is the task I'm giving you, to find those diagonal bits on the elements on the facade. So they are concealed by the wood. And then the lower parts, you can see that they have those stainless steel supports that they are based on. And again, we use the piles because the load is low. So here the wedge piles make sense. And as the last bit, the main entrance has this classroom. Above the main entrance, there's a classroom, and there's this corner column. And it's not a load-bearing one because it's parallel to the facade and not the load-bearing wall. So structurally, this column it hangs on the side of the wall. It's a corbel, so it basically just hangs from the top down. And the joint, again, we came a solution that it's not supported on the foundation. So this right-hand side photo, you can see that there's a tiny little crack there. And whenever I pass the building, I keep checking this crack. Has it, got bigger, whether we need to fix something there. So maybe you could do the same and, when you pass the building, check whether the crack is there or not. But this is a thank you on my behalf to everyone who contributed. Merko Ehitus, Makespace, and Karli will thank himself. I thank him. So I'd also like to thank my team members who are all listed here on the slide. So 12 people who contributed from our company and were involved in the design. I thank you for your attention. And I think Karli will give his talk and then we will take questions. So I'm still here, and then you can ask questions afterwards. Thank you.
Hello, my name is Karli. I am a structural engineer from the company Makespace. And by way of introduction, I'd like to say that Merko Ehitus contacted us and asked us whether we'd be interested to work on the Pelgulinna upper secondary school design. And as a matter of fact, the whole project for us as engineers, that was quite smooth. It is a very voluminous project, but from the engineering side, it's not that complicated. I would describe it as a building which builds itself, and it's not working against you, but it is supporting what you want to achieve with its form. And when I was preparing for this presentation, I had to think quite for a long time. So what am I going to speak about? If everything was going very smoothly and we didn't have any challenges or issues, what is there to share? But usually we learn from each other by listening how different problems were solved. But as I said, in this case, we didn't have much and then I asked the question differently. Why was everything going so smoothly? And my conclusion was that this schoolhouse is an example where you can think about what principles should be needed in designing. And also how the engineering brain is working. And that means that in the beginning I am going to be a little bit more general and philosophical how we entered this project in the stage of working drawings. And I will also give you an example of one solution specifically. As it was said in the present situation, let me say that once again, we entered the project in the phase of operational drawings. And in this situation, it is very important to get to know the project or design as quickly as possible, because the rest of the work is going to depend on that, how well you grasp the whole thing. And you can practically say that the kickoff is given and you have to start working. And the first factors that one should pay attention to, like in the case of every design or every project, you need to ensure a smooth, efficient work for all different stakeholders or parties involved in the project. And if the project is going on smoothly, you don't even notice the deadlines. But as soon as a problem crops up or an issue, a challenge, then the deadline may become the most important thing in the world. And that means that you have to think already beforehand about most efficient solutions which keep the problems away. And in good time, this is the key word here. You have to be ready for such situations. And that means that you have to be relatively flexible from the very beginning, allowing yourself, not just one option, but several ones to choose from. And on this slide, you can see the working drawings of the wooden part of the schoolhouse. Jürgen also pointed out that I am not going to speak much about the architectural side of it. That's the architects who will introduce you to that. But I will speak about the changes that were carried into the design. But as a matter of fact, it happened already in the phase where we were dealing with the working or operational drawings. And all possible ideas and options were tested already beforehand. It's not always the case that things go as you have planned them, because there are so many possibilities. For example, products that are being used, the availability of them, and that means that sometimes you have the need to carry in changes, sometimes bigger, sometimes smaller. I would say that smaller changes, that's something that is continuous. But when we speak about some sort of bigger changes, it may be caused not by human factor, but, different requirements, plus all sorts of, let's say, supply chain difficulties, or sometimes the circumstances around the whole project change. And usually these changes are not programmed into the project. I mean, there is no time allocated for them in the work plan. And that's why I say that it is very important to think through all these possibilities beforehand, to have, so to say, ad hoc situations and a list of possible solutions for all of them that might come along. And sometimes just to find a solution is not enough. It has to be a good solution. And that's necessary in order not to press that big red button which stops the machine. So work has to go on. And I have told you that the solution has to be good. So first of all, let's try to define what is a good solution. I would say that it is the symbiosis of the common playground. Architects, engineers, builders, and this symbiosis that is important for all of them. If we find a solution that everybody would be happy about, that's a good solution. But what would be the way to get there? The first step is based on intuition to a great extent, which means that you have to intuitively work through the project to get the grasp of it, to understand how different systems interact with each other. And then in the course of this thinking exercise, you map the whole route. and you mark the possibilities for changes that need to be introduced. And I would also underline the necessity of the opportunity for repetitions. So if you come forth to a solution now, this has to be a solution which can be repeated in different situations, in different places, because that makes the whole thing more efficient. And additionally, there will always be surprises, and well, sometimes the surprises, analyzing them, you think that, it all started from a very small mistake. So small mistake, but it may have a big impact. And then there are X factors, as always. Now, speaking about the design, well, I said how important it is to get the full idea of this, grasping the project. And on this picture, this is the calculation model that we worked out. And this calculation model, well, the details of the calculation model should reflect the actual real behavior of the structure system as accurately as possible. And the principle is that each model is wrong, but it has to be sufficiently correct for what we want to do. It has to reflect the reality with the knowledge we have at the time of creating that calculation model. And the model gives us the idea about the global behavior of the construction. And if we have that, then it's possible to solve all the smaller issues that crop up in the course of work. And well, there may be mistakes in every calculation model, but as I said, it has to be sufficiently correct. And some principles which we proceed from in our work, there has to be strong tendency to simple solutions. So we shouldn't create complications ourselves. And that means that there will be smaller possibility for pitfalls or traps. Well, what is a trap in my view? Very often you find yourself in situations like that if the problem is complicated, you think that the solution also has to be complicated. But as a matter of fact, it has to be vice versa. Complex problems should have simple solutions. And sometimes you need to take a step back and to see the simple solution to a complex problem. I think this is the most important characteristics of a good engineer. We have to simplify complicated situations into a list of several simple things. And this is how I try to visualize that. The schoolhouse we're speaking about is a good example of this philosophy I was explaining to you. The details we used for joining the posts and beams, we used sort of forks for that. This is the atrium part of the school. And you see on top of the posts, there are a sort of, well, we call them forks. And the principle we proceeded there was that if you put the beam on a post, it supports itself with its weight on the post. And now we need a simple element to fasten it there. And we went down this way. First of all, the original solution, the main design solution was that we were going to use the aluminum concealed console brackets or concealed corbels. This was the original solution according to the main design. These steel elements will be screwed to the posts, and then the beam will be rested on these, and the screws fasten it. But that means that the movement of force would be wood, fixer, steel, fixer, and wood, which means that there will be very different materials in this joint. And one of the principles for an engineer is the less materials there will be in one joint, the easier it is to control different forces. And this solution is very widespread. We also use this solution very often. But in this case, we worked out our own solution. We call it the fork solution, which means that we placed the beam on the post. We used reinforcing screws, and the problem solved. And movement of forces is now wood to wood. Wood to wood, which means the force doesn't need to go through different materials used in the joint. And the solution is better. And from here, you also see the principle which I mentioned earlier, that we have to find the possibility for recurrences or repetitive use of a solution. And we use this fork-like approach also in other joints. And on the drawings, it looked like this. It seems to be quite complicated, very many different fasteners, and the assembly seems to be complicated, but as a matter of fact, it was the opposite. And from the point of view of assembling, production and assembling, and comparing these two different joints, we can say that the fork approach is better, time-wise. Perhaps not so much quicker, but there are less operations attached to it. And if you look at the left-hand side, well, you have to do a little bit of milling and also drill the holes for the dowels. From the point of view of assembly, it is easier because, first of all, this corbel has to be fastened to the post, and it is very easy that you make a mistake in finding the right height. And then you also have to think that the work is being done not on the ground but higher up. And here you have to think about the occupational safety and all these things. And these are all those additional things you need to think about. That's why I dare to say that the solution based on the forks was much better. And this is the example I wanted to give you based on the schoolhouse. And once again, the solution was good, and a good solution is something that all the engineers, the constructor and architect would be happy about. And there are plenty of possibilities for finding such solutions all through the process of the project. And sometimes the good solution doesn't work out, and then you have to live with it. But things that have been traditionally done in the same way, and where there are solutions, there is no need to try too hard to do something differently. If the traditional one is working, so be it. And once again, the repetition, that's the most efficient thing. But then if a problem crops up, then you find a solution, and a simple solution for a complicated issue. So the picture on the left-hand side, the first one, you see how the screws are drilled in for strengthening the beam and the post, and then you support the beam on it. On the third picture, you see the beam already on the post, and the right side picture shows you the screw heads, but these will actually be concealed. And here are the winners. The winners makes this team, and we like to thank also the constructor, Est-Consult, and Arcwood and Western Mix. I'm sorry I didn't add architect Must here, but you will hear what they say today yourselves. Thank you.
We have time for questions. Does anyone have any to our presenters? I have a question to Jürgen. So when I saw how excited you were about the foundations, and over decades that I've been an architect, I've never seen an engineer being so excited about the foundation. So this is your topic, but my question has to do with something else. You said how you tried out different things, the experiments that you tried out with the wind load, but how did you assess the strength of the wood? Because in Estonia we know that the wood is softer, because earlier we used to use wood from Siberia, from northern Finland. So the wood was stronger. So did you just have any tests, or did the engineer instruct which wood should be used? We have a system. So we have people who test the strength of the wood, and they, have the different classes of the strength of wood, and then it has to do with the supply chain and that this particular wood reaches the site. But as for this facade wood, then it was this thermally modified wood. And yes, we used the data from our experiments that the company who supplied the wood, they had done the tests, and they directly sent us the results. But it wasn't prescribed by the architect that you can have so many knots and etc. Well, as for the number of knots, then the strength class is dependent. So the wood itself is strong, but if you have the knots there, then that has an effect, the quality and the strength. But you have to ask the architects whether they actually looked at every single beam and truss and threw some of the bits out. But probably not. Well, when I passed the site, then I didn't see the architect on site, but you never know. Maybe they... Thank you so much. I would also thank the speakers, presenters. I would also like to point out that we have an installation on stage. The author is Erik Konse. Erik has now started to become a designer, and we are very pleased about that. So this installation on stage, 101 wooden columns, posts. This is also the number of parliamentarians in Estonia, and the lighting, half of the posts are lit, so half of Estonia is covered by forest. And for this installation, material was provided to Erik by Rightwood. But we continue with our next presenter. And as you've probably guessed, we've already announced our next speaker, because all of the questions that have come up in the previous presentations, you can ask those questions from Ott Alver, who is our next speaker from the design office, Architect Must. Ott has studied architecture at the London Metropolitan University, and he has obtained his master's degree at the Estonian Academy of Arts. Architect Must office doesn't need to be introduced to you probably, as architects and engineers in Estonia are familiar with their works. They have, over the last 10 years, won 30 awards at different contests, and in addition to being an architect, he also teaches students at the Estonian Academy of Arts who have reached the 4th year in their studies. And in his presentation today, he will also focus on the Pelgulinna Upper Secondary School, Berg. So the title of the presentation is Because of Wood or Regardless, Studies on the Berg Building. Welcome, Ott.
Tervist!
Good morning. I think we could take a quick look at a video, please.
Yeah, I can.
So this was a little teaser. But thank you for the invitation. Architect Must office. Well, I'm very pleased to be here at this wood architecture conference, and I'm very glad to see how the conference has grown. So it's almost like a 3-day festival that we don't just sit here for the conference day. We have talks, tours, technical checks. So it's a nice development from the early years on. But as for Pelgulinna Upper Secondary School, but just a couple of words about our design office. So our office was founded about 10 years ago, and with partners Mari Rass and Alvin Järving, we have tried to sort of create this character, an abstract fictional character, because our vision is that previously architects have defined themselves through their names, through their surnames, and this makes them sort of authoritarian. So we've sort of created this fictional character, Architect Must, and it's a composite portrait of creative and innovative architects. So it's not a kind of a rigid character, but it changes. So as for the school, in addition to our office, I'd also like to mention Pink, who did the interior design, landscaping by Kino landscapists, project manager Olavi Otas, we saw the engineers on stage, and the principal design, Arro and Agasild engineering office, who did the principal design. So there were so many participants in the project, about 20 different companies. I can't name them all, but the competition took place 4 years ago, and the building was ready in autumn 2023 when the first students were admitted. So I tried to divide my presentation into sort of like ideas, so that I don't have such a very strong narrative, but just trying to give you some of the ideas. So the first idea is the context, the location. So this is in the north of Tallinn. We know that this part of the city is going through a lot of changes, and the school is just amidst those changes. So the state is developing a network of schools, and we know that there was a need for one. There are other schools in the area, and of course this is a new building that draws students from other schools. So the building itself, the structure, it's sort of like surrounded by apartment houses from the 1960s, and also the Merimetsa Park forest. So it's kind of in between the two. So nature is right outside the school building, the park. So it's like a mediator between these two, the urban and the park. So when we look at landscapes in Estonia, when you look at an old farmhouse, it's so natural there in the nature, in the natural environment. I think in Estonia, our foreign speakers, presenters, they come from perhaps slightly different backgrounds, where the natural aging of wood, the patina that it gets. So we know and we wish that this schoolhouse will carry the same idea, that at the moment it's brown, but eventually it will become grey. This is a photoshopped version, but this brown wood on the facade will become greyish. So this is the idea that we also had, that it will kind of blend in with this park and forest. The second topic, or the idea, is typology. So with school buildings in Estonia, in our office, we have had a lot of cases, projects, designs of schools. So often you participate at a competition and you do what you have to. And in Estonia, we have then a national program for designing schools. So we sort of think of it as a module, 35 by 35 meters. And this module, you can pack inside the classrooms in the perimeter, and in the middle you have the utility rooms. So this seems to be a unit, 35 by 35. And with this particular building, we took 3 of these units, 3 modules. So this was the necessity for the volumetric needs 8,000 square meters, and how to connect these 3 parts. So the volumetric whole is built on repetition. So it actually fits in with the apartment houses, their height, and the forest, the park. So this is the intersection and joining and the perimeter area. So the right-hand side volume has the technical parts, and we try to shade them. So that's the highest part, then the middle part, and the left-hand side is then the sports hall, the gym. So this is the structural model. You have probably seen it before. 85% of the building is wood. The load-bearing structure is wood, which is sensible. We can go further. The further buildings in Raeküla, for example, they have got to the stage where the evacuation stairs are also built of wood, and it's great to see this development. I might skip those BIM model slides, structural model, electrics, etc. And I come to wood, the actual use of wood. So in the design competition, the idea was that this natural house is being built near the seafront, then we grasped this idea of using wood and tried to convince the state that we need to test the use of wood in public buildings. And it's not just we replace the concrete with wood. In principle, you can always do this. But in addition, through these public buildings built on such a large scale, testing wood, testing all the different opportunities. So we had this double facade, then interior elements, the acoustic panels, all the stairs, everything is built of wood. So we looked at the different usage opportunities of wood, and that wood can be used to build. It may not seem still so natural, but 10 years ago, if you think about it, we didn't have very many examples in Estonia. So by trying out these things, we also see how it stands the test of time and when several hundred people use the building at the same time. So this double facade idea meant that the building has to be democratic, that this is how we would like our schools to be, how we'd like them. It's not sort of the top-down hierarchical institution where the teachers teach and students study. So this double facade, it sort of blurred the boundaries of the building. And there's like a 300-meter-long bench outside with seating corners, so it means that it's welcoming, and then this glass surface offers passive shading. So there are many reasons for why we did this. So what we realized with this facade, as it is massive, and as mentioned, 33 kilometers of trusses were used. So we couldn't have like a free flow mix of elements, but repetition was very important so that we can handle this mass of the timber. So we designed for 3 months, Jürgen, Karli probably another 3 months, and then it was also built for another 3 months. So the solution takes a lot of time. So this repetition element is important. Other challenges. So can you have a wooden facade without a top cover? So, you can't have those things just hanging out there and not be covered up. So what we did is that we sort of designed those trusses where the upper surface of the wooden profile is at an angle, and that there are sort of aluminium composite plates that were used upon joining. And then those covering caps, so those the tops, thousands of them that we had to create. And then another challenge, should we cover it with paint? This is something that we have also been dealing with, and we thought that the best way is that we don't cover it with paint, because then we'll have another problem, which will be maintenance. So maintenance and weatherproofing. So maintenance is in the project, but people don't actually do it. So we had this thermally modified wood as a solution. We sent the wood to Sweden, where WoodSafe, basically in vacuum chambers, basically like pushed this polymer-based fire retardant called WoodSafe into the pores of the wood. And this should be like this for 30 years. So it's very interesting to see how in the next sort of 30 to 50 years this wood is going to behave, so to say. So we tried our best so that the wood would keep. Fire safety. The building has a large atrium through different floors, and we couldn't avoid having sprinklers, so we have high-pressure mist sprinklers, and there's a local water tank with a 1-hour reserve. So in case something does happen, then these mist sprinklers won't cause too much damage. A-class material is behind suspended ceilings. So there is a requirement that you have to have A-class material behind suspended ceilings. Then fire zones, there's a retardant varnish as well, fire retardant varnish. And then, yes, the two different zones that the building is divided into. An interesting topic had to do with the neighbors. So this is the plot. This is again the not in my backyard culture, which is becoming very topical. So this is an aerial photo from 2021. So all of those apartment houses, they were built after 2000. And the detailed plan indicated that, yes, this site will have a public building. So it was sort of an empty-ish area. It wasn't really forest or park, just a couple of few trees. And then 2022, 23, so what it looks like now, how this public space has become used by everyone. So with the landscape architects, we kept most of the trees between the apartment houses and the school, so we couldn't really have any outdoor playing areas or anything there. But it seemed that it has worked, that the neighbors really fought for keeping these trees. It was a good reason, so there's a bit of a buffer zone in between. So the actual state program of building those state upper secondary schools, it's a great program, and I think it's proper and right that in Estonia we dispense quality education. We have 28 upper secondary schools that are run by the state. I think in 2013 the Viljandi one in South Estonia was built, and ever since then, for 10 years, new schoolhouses have been built, so there are public programs and we can compete. But I'd like to talk to you about this change. If we look at the internal structure of schoolhouses, we have this school on the left-hand side, a historical school building from the 19th century, a school in Pärnu in the western part from the Soviet times in the 40s, and the Berg. So you can see that the public rooms were always separate, behind closed doors and walls, and they cannot be used universally, and they are not connected to the outer space. So the new buildings, they also give us specific tasks, that the public areas are open to everyone. So basically the room meets its specific needs. And as many more schools follow this principle that there is this shared universal space, and the society basically wants this, that all schools would have this. We know that Realkool, located in the city centre, is going to have a new annex which will follow these new principles. If you recall, in the summer, all architects were very excited about this report that was published by the ministry about the costs of education in Estonia, that the report said that Estonia spends twice as much on education and investment in education, and that we also actually for 30, 40 years haven't been able to invest in our schoolhouses. So we are trying to catch up with these new school buildings, and the Estonian structural funds, the EU structural funds money can only be used for buildings, so not for paying teachers' salaries. So that is why I would actually like to say that it is wrong what the analysis said, that we spend too much on luxurious schoolhouses. It's not true. So it's been a success story. School buildings always win awards in Estonia, and this tendency seems to continue. Why is it that we are trying to undermine the situation? Now about the interior design. So Pink were the interior designers, and I think we had very good cooperation. So we kind of breathe the same air and how we define the interior and exterior space. The school, it teaches climate change. So all the schools in Estonia have focused on a different sort of topic. So Berg specifically focuses on natural sciences, so what they teach is also in accordance with the building. So this may be a bit naive, but so the environment isn't rigid and geometrical. So we have this image of a staircase that's inspired by a natural hillside, that you can see those sort of steps, that instead of having a classical auditorium, we have created this hillside with the different levels and steps, and this changes the dynamics, and you can sit and make yourself comfortable wherever you want. You know, it's a different attitude towards using an auditorium where you have a stage, curtains, and everybody sitting on the floor. So there are screens on different sides of the building. It's not just a box. There are 3 live plants inside the building. So in the library, in the foyer, in the atrium. And another challenge is that the depth of the building is 35 meters to how do you get light? So we have the skylights, as many skylights as possible. So you can see that the skylights are efficient and that the students use the rooms. Maybe just a few problems, issues that we had. Erik asked me to focus on the pressures that we had. So again, not enough space, and there weren't enough solutions how to address this space. So 2 square meters per person in a classroom, but not in the communal areas, only 1.5 square meters. So this corridor zone, we need to have them comfortable so that it's not just a transit zone, that there are just opportunities in the corridors to just, sit in a corner somewhere. So 1,200 students. At the moment, there are 720. Next year, there'll be 1,080 students. So there won't be enough space for everyone. And how can we affect this, that we create this link between the internal and external space, that we have the pavilions outside, that in May and September, perhaps when the weather is better, then the students can use the outdoor space, so everyone can be together. As we are here at a wood conference, and I thought that I should talk about this, it's important to cover this. We compared the CO2 footprint with another school which is built of concrete. So 2 of our designs were completed at the same time. At the end of 2023, similar buildings, perhaps the Mustamäe one, there were budget differences. So this is the structural model. One building in Mustamäe is concrete, Berg is wooden. So they are very similar schoolhouses. And Kadrian Kertsmik, she did this life cycle analysis, and the difference wasn't very high, just 10%. So what is it all about? So when we look at the carbon footprint, the life cycle generally, and the life cycle calculation or analysis, then you can see that in the long term, the use is the largest part. So are we talking 50 years, 100 years, 200 years? So this will also affect the footprint. So as for production and construction, then you can see that the percentage there is relatively low. And if we look at the construction stage, then the difference is about 20% between timber and concrete. So the structural elements, yes, wood is better, but if we look at the whole integral picture, then it doesn't make much difference, because if we lose the structural element parts, then yes, we get a little bit of a benefit. So we can have different types of analysis. We look at different materials, their averages. So this is another important topic. But Jürgen also discussed it. In case of the footprint, we look at where the building is. When we look at the geological map of Tallinn, so Pelgulinn on the top, Mustamäe down below, the soil is very different, and this is also to do with the different foundations. So often foundations are not calculated at all into the footprint. I don't know if in Estonia we should do this or not, so this is a discussion topic. The architect can't really choose the location of the building. You know, we are being told that that's the site. You designed for this site. So do we include the foundations? Should geology, guide planning, designing? So instead of looking at the average, we should look at the EPD, the Environmental Production Declarations. So this means that we, as creators, can look at what is reasonable and what is reasonable to achieve certain results. So I'm not having anything against wood, but we should look at the broader big picture of things. And some more challenges. What has been criticized is, of course, the price and the Mustamäe Gymnasium was 1,800 euros per square meter and Berg was 3,000. So yes, during the procurement, prices were different. But this was such a difficult situation where the construction price index rose by about 80% in the same year. And the price of wood went up as well. Basically 100%. The risk coefficient is also something that we have to continue. We have the know-how, but still not enough know-how, and there aren't enough producers. There are a few producers only who could, stabilize this wood market. Then the overheating of rooms is also a topic. Schools have had to deal with it, and all school heads have said this, that in the summer it is very hot inside the classrooms. It's not that we haven't considered cooling, it's just that if it's 28 degrees outside and you bring this into the building, then we can pre-cool maybe a bit, but that's all we can do. So school buildings don't have active cooling systems. They're just not allowed to because, students are not there in the summer. So the question is, do we need to have the HVAC? But summers are getting hotter, so this is a challenge. And then who is this school built for? Who was it built for? So we think that it was meant for everyone, not obviously the students. So the space, our idea that it's not a hierarchical space, but it is space that is unhacked by the students. They can sort of squat there if they want, and that they bring the space closer to themselves, that they feel that it's theirs. And I think it has worked. We're very happy about this. We have told them that please adapt this space. And it's great to see that the School of Architecture, Arhitektuurikool, is also using it. They have exhibitions that they hang up. They are testing the space. What can you do there? And that everyone who uses this school has different opportunities. And another video that I'd like to play that illustrates this.
Ja, aitäh!
Thank you. Thank you, Ott, for this inspiring presentation. I have a couple of comments. So my first quick comment has to do with what you said about NIMBY, not in my backyard. It seems to me that in Estonia we are sort of even moving towards banana. So how do you feel about that? And then about the funding, the drama that we had, that we spent too much money building luxurious schoolhouses, this report that was published in the summer. From structural funds, we won't have any more funds, so no worries. But architects, engineers, you have the know-how. We have the know-how. So how to design these types of buildings? So what do we do with this know-how? How we'll be able to use it? So maybe for other types of buildings. So this was a sort of a general philosophical question, comment, but we have some specific comments and question. So via Workshop, we've got a question. Thank you for this overview about the design stage. Do you know the maintenance cycle for the facade, and what is the usage age? Well, I don't really know, honestly. The manufacturers, they have sort of given guarantees, and if you ask, do you give a guarantee, then they say, well, we don't quite exactly know, we are testing, so we are trying out different solutions. But as for this particular facade, then the issue is that it's quite a complex situation. We know that, you can maybe replace a couple of elements, but we did invest a lot into this facade. Financially, time was an investment. We tested, can we actually build such a frame in our climate? We send the wood to Sweden to be thermally modified. Will it work? And if in 15 years we see that that's it, no, we can't use it anymore and we have to take it down, then we'll be just wiser. Yeah, so using something like this out of glulam. So we had also support by the manufacturers, the large manufacturers who wanted to find out how it's going to work out. But as for the NIMBY, it's an issue of communication, communicating information. The ability as a society to talk to the neighboring people and show them what's going to be there. We have built this school for everyone, and they just didn't understand. And then Merko, the builder, said that, they're going to come and throw eggs at us tomorrow. What are we going to do? But it's a win-win situation. But it has to do with communicating the information at the right time, and that they wanted to take us into court. Thank you, Ott. But before we continue with our next presenter, Ott, you're welcome to take a seat. We have a last-minute questions to Jürgen Einbaul. Again, there was a thank you for the presentation. As it's the same topic, the same building, the same structure, the same design. Jürgen, are you still here? Are you close? Can I see you? Okay, you're here. Could you just pass the microphone to Jürgen? He can answer the following questions. So you were referencing a section of the building with the soft soil and the wedges that went down in this particular section, and then all the different layers of soil. We don't have the slide, but could you comment? I'll just try and describe this geological section. Yes, there's soil, then sand. How many layers do I have to tell you? So how deep do the wedges, piles go? And what are the different layers of soil? So sand, then the softest part, which is clay, and then sort of a medium soft marine sand, then again clay, and then finally there's like a harder bit of sand. So we didn't get all the way through, so our piles went to layer 6. So layer 6 was strong enough. Yes, then again, yes, layer 7 is softer, and I think the ground was, lowest level was the bedrock, I don't know, something 25 meters. We didn't go that deep, 25 meters to the bedrock, to layer 6. So I hope I answered the question in detail. So wedge piles, they were just through the sandy layers, because we can't have them longer than 3 meters when in that case, we should have gone through layer 5, which is 7-8 meters from ground level. So these are different types of piles. There's another question from Ukraine. Sergei is asking, has the engineer taken into account when... Okay, so all the different things that could attack the building, all the different weapons. So no, it's not meant to have bombs flying on it. So this is a different topic of building shelters. So shelters are a very different topic. So if we had to build a structure that should meet all of those criteria. Another question from Ivar. Ivar Tambovsky from Rightwood. I did put my question in workshop. What could you take this question, please? So the CO2 comparison with the other schoolhouse built of concrete. So the methodology, do you know what it's based on? And how does this take into account the biogenic carbon? And is it done before the database of environmental impact that we're complying at the moment, or was it based on the EPG? So this particular comparison analysis was done before, so it's based on the average data, so not EPG based, not environmental production declaration based. So I think it's the embodied carbon that we're discussing here, whether this was taken into account or not. Because if you take into account the biogenic carbon, it means that in 50 years it will still be embodied. So if it burns or whatever happens, then we shouldn't take it out of it. So yes, the carbonization is not taken into account. Thank you.
The next speaker is a person representing Snøhetta Studio, Innsbruck, Martin Zisterer from Austria. Snøhetta offices known all over the world. They have designed very many public buildings, very many special buildings, many offices all over the world. And Snøhetta is also known for the opera house, which is decorating the Oslo city center, which was also the laureate of architecture 2009. And Martin is going to tell us about his experience in designing bigger and smaller buildings.
So, hello everybody. I'm really grateful to be here today, have the opportunity to present Snøhetta's work here in Estonia. I'm really thankful for having this chance. I think we have some beautiful projects which we like to share. And if you wonder about my strange accent, it's not Norwegian. I think it was part of the introduction. I couldn't really follow it, but it's Austrian. We have a studio in Innsbruck, rather one of our 9 studios. It's one of the first studios which was established about 10 years ago. Outside of Oslo. And I would like to start with explaining a bit who we are. Here you see a picture of us just recently in September. We do this biannual walk. We meet up in Oslo and have these Dovre conversations, as we call it. It's a chance for us to exchange across the studios. And this photo is taken just right before we climb up to the Mount Snøhetta you see in the background. We never had that good weather as we have had this year. Usually you don't see the mountain. So this was really a great time this year. We run studios, 9 studios, as I said, all around the world. And just like how Innsbruck blends in with all these amazing cities from Paris, New York, Hong Kong, Adelaide, Melbourne. That's really nice to see. We have a multidisciplinary approach. We have landscape architects, we have product designers, we have artists in our teams, which our projects, I think, benefit a lot from. Coming back to these Dövre conversations, it's a chance for us, as I said, to exchange. We get all the people from all the world, which is around 400, and we help each other the way up. I think that's important. But we also have the chance to walk and somehow talk to each other, get exchanges, but also somehow think about who we are, where we are, what places are we dealing with, in which landscape, which surroundings are we dealing with. And I think that's something that's in our projects. You can find some of these thoughts in many of our projects. It's more about creating places. It's not so much about the building, it's really about creating places for people. And these images are from the Oslo Opera House, which many of you might know and maybe even have visited. But we like the idea that people use our buildings and there's not a big border of interacting with our buildings. You can ski them if you want to. You can also slide on your belly in the lobby of an opera house. I think that's just great to see how kids and tourists and the public interact with our buildings. And staying within the Oslo Opera, I think it's interesting to mention that the heart of the building is this concert hall, and it's fully clad in wood. It's oak wood, and there is kind of a transition between the hard surfaces from the outside, the vibrant city life, the bright space you have in the lobby, and then you're guided through the staircase, cave-like spaces into the main concert hall. And the wood somehow contributes to being a buffer between this vibrant city life when you're entering the concert hall, calms you down, creates a special atmosphere, and then you enter into the concert hall. It's also fully clad in oak wood, smoked oak wood, which is a fantastic space, and very important for us that the people and these things that the people interact with are created in wood. Also in this project, which is the reindeer pavilion, it's just at the border of a natural, what is it called, a listed landscape, and it gives you the chance to see wild animals like reindeers or musk ox, like in this case, in their natural habitat. The idea was initially to create a museum for reindeers, but we thought that's maybe not appropriate. Maybe it's better to show them in their natural surroundings. And we came up with the idea of this shelter, and it's based on a quite simple idea of this rural shelter sitting around a fireplace, but it's also inspired by local craftsmanship or by forms we find in the nature, snow that is melting away. And we like to then build models, translating these thoughts into a physical model, also giving it some tests on wood already with our own robot to see what it might at one point look like and feel like even. And then it's going to be built. And in this case, you see how it's built, because I think people usually think it's a big block of wood and it's such a waste of material, but it's actually quite efficient. You pile these different blocks and they are connected with wood plugs, hardwood plugs, and there's not a lot of material waste. Here you see the big middle, and you see also the cavity underneath. So it's quite a, I would say, effective way of building this structure. This is a view you get when you enter the building or when you approach the building. This is outside, and then you have the opponent on the inside, which gives you a view like this, and frames the landscape, and by doing so, highlighting what's already there. This thing got copied quite a lot. Some hotel managers in Austria thought that's such a great thing. We want to have that in our hotel. They just did a photo montage and said, okay, now we're going to have that. There are some better studies maybe, but some I think failed and don't match with the original. But it's always fun to see kind of replicas of this so iconic building. A really small one, but really iconic, I would say. Increasing the scale, coming to cabin, which we did also in Norway around 2015. There was an existing cabin which was there for ages, but at some point got struck by a heavy thunderstorm, which also shows that nature is shifting, that we have to deal with the climate crisis. It forces us to think and approach our projects differently. And we came up with the idea of this gate-like situation, which defines a clear spot which you need to find while walking through the mountains, and creating an inner courtyard which would allow you for, in the summertime, have a really nice time in the outside. This is what it looks like when it's finished. And I would like to focus at this project about the atmospheric qualities of wood as well. I mean, it's a spatial quality, of course. It's a strong connection to the outside, but as you can see, all the details, there's not much effort in it. So all the frames around the wood, it's just like you receive them from the mill. There's no extra effort. It's really robust and totally simple. But I think the spaces as such and the wood with its particular quality give a lot to the project. That's something we also tried for a shelter and viewing point in the Austrian Alps. That's a building in a ski resort. That's what it looks like from the outside. So it's an extension to a newly built chairlift. It has some ideas from local building traditions. These are farmhouses which are hundreds of years old. The living rooms and the kitchens, they were mainly built in wood and have a really nice atmosphere. And it's great to see these structures, these wooden structures, after hundreds of years still working. The facade is created from shingles. This is a local shingle maker. He splits the pieces. He's not cutting them. He splits them, so that keeps the wood strong, and it's easier for the wood to resist to all the conditions, to the surrounding conditions. And this is attached to the facade or the roof, whatever you might call it in this section. I don't know where's the border between the roof and the facade. But that's interesting to see that you have local building traditions attached to a new architecture. This is again the view from the inside. This is when people use it. This is a picture of the opening. You see the local brass band hitting the stage. And it's great to see how people occupy these spaces. Also, we go there for ski trips. We gave it a test if it really works the way we intended it. So it's a consumer-free spot that's quite rarely in ski resorts. Usually you have to go to restaurants. For families, it always gets more and more expensive to spend ski holidays, ski days. So it's a contribution to make it a bit more approachable, I would say. Again, the window framing the view in the winter, putting some extra highlight on the surrounding landscape. This is what it looks in summertime and from the outside. And what's a funny thing is that you have this big window which gives you this amazing view. But also on the left side, you see there's this small spot which gives you this view, as spectacular as the other one, I would say. That's great to see. Another step bigger, an office project just next to Innsbruck for a travel agency who approached us for a new office building. And in this project, we tried to, for the first time, I would say, it was around 2015, really challenge ourselves and try to get the most or the best sustainable building which we could do at that time. You see it's the black one in the foreground. Underneath, you see Innsbruck. You see the mountain chain on the north, quite impressive. For me, seeing it every time, every day, I think it's still impressive. And it's a really nice spot just within the forest. And it's clad with a steel mesh to allow the greenery to grow on it, to add some shade to it. We try to keep it low-tech, so it has an automated natural ventilation. It has a green facade and carbon-reduced materials, so actually quite simple, I would say. Another image, here you see a section through it with all the measurements we tried to apply to this one. And important is to see, or process-wise, it's interesting that we really had an intense time with the client, exchanging what the building could look like and how they would want to use it, because we believe that also this gives a real sustainable benefit to the project. Because if they like what they are doing, if they like what they get, then they will use it accordingly, and the building, we assume, will last for quite a long time. Some interior shots. It has a real great atmosphere. It's directly connected to the forest outside. And with these simple measurements, like the natural ventilation, it creates a special atmosphere. The green facade is a natural sun shading, which is a factor which we need to tackle more and more. In winter, the leaves fall apart or fall down, and then you gain the passive heat of the sun. Yeah, and a great benefit by doing so, you reduce the operational carbon by 70%. But even more, it gives a nice outside space as well. So that's not just the benefit for the cooling, but also giving the people working there a nice outside space just connected to their working place. This is what it looks in winter. And in total, we achieved to reduce the footprint by around 350 tons. That's something. I guess it could be even better, but that's something. And with a project in Munich, we tried to scale that, and we asked ourselves, how is it possible to scale that? How can we reduce on a commercial building like this one, which is placed in the Werkviertel in Munich? How can we reduce the carbon as much as we can? You see the site, it's right underneath this bridge building, which is a really strange situation. You have a parking house which will be torn down because it tends to fall apart. And this one will be replaced by the new office building. But it's not just that, you have a lot of demands. The city is asking for even above ground parking, as they do have a parking garage already. They would want to see above ground parking in the future as well. It's Munich, it's a car-driven city. And we came up with a special idea, which I will talk about later on, tackling this topic. But there's a lot of demands represented in the building. You have the commercial part in the plinths, you have the parking, office space on top, and everything underneath this bridge building is quite challenging. Explaining how the project evolves, you have a quite strong north-oriented, north-south and east-west-orientated plinth grid, and on top the office spaces orientated towards the media bridge, as it's called. We have inserted these cuts to decrease the depth, to get as much daylight into the building as possible, and also giving it a specific form in a way, because office buildings in that scale tend to be quite generic, but we think it's also important to give them some kind of specific appearance. This is what it looks, or what it might look in 2027. Talking about the structure, we have, unfortunately, a basement in concrete, in situ concrete. Then we have a plinth, which is built in a hybrid construction. And on top, kind of mass timber approach with CLT slabs, wooden columns, and delta beams. Below, on -3, you see an ice storage. which is a great thing. This allows the building to be quite autonomous towards heating and cooling. There are not so many examples so far in Germany, around 10, we assume, but maybe not even in this scale. So it's kind of an experiment. We're really looking forward to see this because it's for the building a great benefit and makes it, as I said, quite autonomous. All these demands, as I said, were quite challenging for the structural engineer. He came up with quite a lot of options on how to solve these different demands for a commercial plinth, the car park, and the office on top, each of them having their particular needs. In the end, it turns out having a concrete basement and then also building parts of the car park in wood seems to be possible, because at some point, if we consider that the cars become less and less important, we would like to take that ceiling out and create something else in this space. To combine these two grids, you need kind of a transfer level, which is a grid system. And on top, you have the mass timber office parts. By doing so, we gained, or we could reduce the footprint significantly to a minus 3,000 tons about in the first phases. That something could be better. I think we learned a lot in this project again, and we will keep on challenging our clients to even invest more on sustainable designs. This is what it could look like in the future from the inside. And talking about the structure again, on the right you see already a scenario which could be if you don't need the cars anymore. Because right now you have a ceiling which splits or separates these two stories, and this ceiling is built in wood. And we assume that it's easier to take out this ceiling as it's built in wood, as if it would be built in concrete. And then you could come up with different scenarios. This could be kind of a conference space like this one, could be kind of workshops, whatever. The only thing you need to do right now is to create 2-story high columns and design the building in a way that the horizontal stiffening also works when you take out the ceiling. Then it should be possible. So we'll see in some decades if this ever will happen, but I think it's a great idea, and also great that our client took this idea with him. Another view from the outside, talking about the facade. It's a wooden framework facade, has recycled glass panels on the outside, fins that also provide a passive shading, and an aluminum canopy, dividing the stories. A view from the east side, and then talking about, or moving to Switzerland. It's maybe not the biggest project, but it's one of the buildings that is mostly built in wood. It's a school building for a boarding school, an international boarding school, which is most of the time or most of the year sitting at Lake Geneva. They have close to Lausanne a campus, and for the winter months they move to Gstaad. So they take everything they have, all the books they have, all the teachers they have, all the pupils to Gstaad for doing winter sports, because that's important for them, that's part of their culture, that's part of their educational idea. And it has a long history, so they moved to Gstaad since 1918. This building, or this picture, is from around 1918, and you see that there is a, I mean, it's hard to see, but there's a thin line. So it's the moment when the railway was established in that region. It also brought tourism to that region, and it's not as picturesque anymore as it's on this picture. So it's much denser now. Grand hotels were built at that time, and changed the landscape quite significantly. Why am I telling this? Because it's important for us to find the right context. We're dealing with a quite big building for a village like Gstaad. And the question is, how do we manage that it's not an alien sitting there, but still can be its own or have its own position, be a contemporary presence in the future, but also be part of the building history. Over here you see these long two lines, that's the railway station, and just next to it you see the future building. This is what it could look like. That's a picture of the model. And you see that it has this cut in the middle. So it's divided in two parts, because otherwise it would be too long. There is the railway in the front, and in the back you have a steep hill. So we moved the building, or the right part of the building, towards the lower part of the hill, and we cut the left edge of the building to not get too deep into this hill, because that would increase or would ask for a lot of groundwork, and we wanted to avoid that. This is what it could look like one day. Right now it's in permission phase. And there's one very important space within the building. So the outside presence, that's important for sure. But for the school, this picture was where they feel represented the most. So that was the moment when they saw this, they said, okay, that's the way how we want to have our Gstaad building in the future. You have a long cascading staircase, and it always defines kind of breakout spaces where they can do individual teaching. And this great space will also be represented during the night, of course. It will be illuminated. Here you see a section. You enter the building on the right, and it leads you up to a library and learning center, which we're really looking forward to see. We like the section so far, but we're really waiting for it to be built and see what it's going to be. Getting a bit more technical, here you see a section where you see the ribbed slabs. We do need the concrete basement, as there's not much or not enough space on the site to place these sports halls somewhere else. We had to bring it underground, but above ground everything is in wood. And also here we challenged our engineers to come up with the most effective solution. For a long time we tried to go for the third version, a ribbed slab with a ramped earth arch in it, which was developed in Switzerland recently, and in relation with an Austrian, or in cooperation with an Austrian company we know quite well. But it turned out that it's too cost effective, that it's creating too much height, it's too heavy. So it wasn't the right solution for our spans that we needed. So we ended up with a quite classical solution, these timber ribbed slabs, which is quite traditional, I would even say already, but a great solution for the needs of the school. Here you see the roof. Another important topic, if you remember, these cut through the building, which is also represented in the roof structure. You have an orthogonal grid on the school classes, and on top you have this shifted grid, and it appears in the end quite natural, I would say, and also referring to traditional building or construction methods we know, or images that look familiar, I would say. And it's great to see it in a contemporary building again. This is what the roof could look like from the inside. It gives you an idea where you are, which direction is important. And coming back to this image, already my last slide, because what we like most about this idea is the fact that if you consider 400 pupils coming from all over the world, learning, studying in this building, and if they finish school and spread out in the world again, maybe they take some things or some ideas that we had in this building and spread it all around the globe. And I think that's just a great idea, and we really hope to see it built in the next years. So, thank you very much.
Thank you, Martin. Kas meil on küsimusi saalist?
Do we have questions?
So, when you come from Innsbruck and all the culture of Austria is quite much, let's say, familiar, and its wood is very familiar material since hundreds of years. What is the part of the projects made in wood for you in Snøhetta in Austria? And the second part of the question is that Snøhetta has a specific aesthetics, culture, design, and how much and how you spread it around your area, and how far is your work area from Innsbruck?
So from Innsbruck, we try to work in southern Germany, in Switzerland, northern Italy, Austria, of course. We also had a project in Slovenia, in Bratislava, so that's the region we're dealing with. And cultural-wise, I would say there is not a real design language, maybe. I don't know if you feel the same way, but I think that there is not a real iconic design which is represented in each of the projects, but it's more of an attitude. It's kind of, as I said in the beginning, creating these places rather than buildings, being generous, giving something back to the public. I think that's in all of our projects. And this is kind of a cultural thing, you know, it's not a design thing. And the first question, amount-wise, I would say it gets more and more as we challenge our clients more and more to build in wood. It's hard to say in percentage, but I guess we're around 80% now. We tell them immediately, so if you're not going to do it in wood, maybe we're not the right for you. Maybe you need to ask somebody else. And if we have the feeling that they want to go the same way as we do, then it could become something. Yeah.
We have been talking about the schools today quite much, also in the previous presentations. And it has been in my mind that when I went to the school, then it was in the town Viljandi. It was the typical school from Soviet time, typical project which was spread all over the Estonia and also all the other small republics of Soviet Union. And now, today, my understanding is, and let's say that's the attitude of Estonia, that when we make the state gymnasiums, then the results are always unique. They are like contextual, they are chosen from the best choice available through public competitions. And my question to you is that how much do you have in your practice the repetition of the projects? Is it possible that you make a good school in Gstaad and you can use the same model of doing the project or the elements again? Or is the process for you also that every project always is a new thing?
It's like that. It's always a new thing. There is no repetition. I mean, we do have a graveyard of great ideas. And we sometimes look back and say, oh, that's a pity that we never built this one, and maybe we should try to bring it back at some point. But also in this case, you need to adapt it to new situations. I think that's in our genes somehow. We have to start from scratch. There is not something that we just take out from the drawer and use again. Yeah.
Thank you. Thank you, Martin. Nüüd edasi läheme.
We have a lunch break, and our next session will start at 1 p.m. Thank you and bon appetit.
Tere tulemast tagasi.
Welcome back after the lunch break. I'm very pleased to introduce our next presenter. Tim Scott-Heimsvik has 50 years of expertise in the field of timber design and engineering, and he's from Norway, and he holds a master's degree from the University of Newcastle in the UK, and he then specializes in timber design in a corrosive environment so that the building is sustainable and that it can deal with moisture management. And the presentation is focusing on a roof structure and the building design and reality and how to navigate between these.
Thank you so much for the nice introduction and for having me here. I'm going to take you all through an exciting journey. The theme is being bridging design and reality by looking at a swimming hall facility that I've done the design for in Oslo. We're going to dip into navigating the challenges we had during the development and unexpected things that happens during constructing. So here we have a picture from the structure, or rather rendering for the roof structure with about 4.2 meters tall CLT glulam structures, the way the architect wanted to have it to look like before we started. This was basically the drawing that we got before we even can start to see how we should fix it. And our aim was to develop it into this, how it looks today, 2 months ago. So firstly, like we are here in Tallinn, the structure is in Oslo in Norway, and I live in a small city in Molde, which is basically middle of nowhere, and still capable of doing nice wooden structures like this. So let's go deep back in history. Back in 1976, the first swimming hall, the same place were constructed with the concrete pre-stressed beams. As with a lot of other swimming facilities in Norway, these were never properly maintained and had corrosion problems, and came to a point where it was no longer economically to get it up to date. Hence, it was torn down, and this concept here with the roof structure were the winning architectural concept. The new swimming hall includes a 50-meter swimming pool, diving pool, a learning pool, swim out, outside 25 meters pool, and have included functions like green roof, solar panels, and everything you need for today's climate. The architect's original vision was to create a space of top of the swimming pool that was supposed to have all the technical aspects within the structure, within the swimming hall, and this should define a space as well as create a space for those who use the facility. So how do you start by doing stuff like this? Well, we started by actually trying to convince the client that this was actually feasible. We invited, much like this, had seminars in Norway. We invited expertise to talk about theory, is this possible, and included furthermore different field trips that we went through Europe, different manufacturers, different projects, and took with us early sketches, talked up to different experts, different professors, and had their opinion if this is feasible or not, and came with a lot of good suggestions. So this is the floor plan. We have about the longest 42-meter span and the shortest 60-meter span. No wall, no two beams are the exact same length due to the incline, the facade. So as any other structural engineer, the first tool we take up of our tool bag, we are going to solve long span. That's trusses, right? So that's the way we started as well. It solved the issue. We got long trusses. We can clad it on the side to get the egg cartridge look that the architect wanted. However, since this was supposed to be like a space within for the whole roof structure, we couldn't really use huge trusses inside, but that took up all the space. Hence, we went to the next, tried to do double trusses and clad it on the side. It solved both the problems, but was not economically because you had used way too much timber. And hence, we tried to think outside the box and use the actual architectural rendering, the drawing, the actual shape as a load-bearing structure. Hence, we came to this kind of bridge-locking box structure. This meaning that we have to divide it up in several pieces, and with Norwegian law, you are not allowed to exclude, in public tender documents, exclude all different manufacturers. Hence, we had to go through Europe to look at the different manufacturer limits for both thickness, length, and so on, to make sure that we designed a structure that a lot of different contributors could deliver. Then we divided it up to different pieces, trying to look how can we solve this by putting it together in different material, different sections, cross sections, and so on. Did different calculations and basically iterated ourselves. What is the most economically for cash and stiffness? Basically, we want a structure that is stiff and cost at least. So we iterated us to the best possible solution, which basically is this structure here, which a cross-section of about 700 millimeter glulam beam in the bottom, 18 degrees inclined inside, 10 centimeters CLT walls, panels on the side, and a 3.5 meter CLT panel on the top. These are spaced out every 4.5 meter, and you have like a middle plate in between to gain the same correct spacing. 90 degrees on these, you have acoustic elements that have the exact same shape, but they have like a small like coffin in the bottom, glulam beam in the bottom, and then you have a prefabricated acoustic elements that placed on top of this. And this combined has the function for the acoustic in the bathroom facility, and we also have steel rods in the bottom from one acoustic element of one coffin to another coffin, which basically are tightening to push into the main load bearing to work as a secondary load structure to reduce deflection of the structure. And then, obviously, throughout the process, we went with a lot of different models. We created models with both paper and with different wood materials to try to see how this would look. We actually went as far as quite early and built scale models one-to-one of the facade in the architect's backyard to see how this would look. And during a lot of this process, we are simple engineers. We do not know how to do like such innovative projects all by ourselves. So, like I told you, we had field trips. We were in contact with a local university and had a group that did a bachelor thesis on one of the connections, with seminars with all the wood people in Norway. Basically, what we did was like, not a huge room like this, but we still invited like 100 people, and we had all the drawings up on the wall, huge A0 drawings, and we did mostly like this. Different possible solutions, different connections, what works for the architect's perspective, what works for the engineer's perspective, what works from the fabric, what works from the montage people, and try to put pieces from every single thing together and see what will be the best solution for the project itself. And this soon developed into like 1 to 20 scale models of how we wanted this to put together. We actually could create pieces that we actually wanted to build and try and put it together ourselves and discuss if this is feasible or not. So the structure itself, let's talk about what it really is. It's just an architectural marvel, that indeed it is, but it's more than just the architect and the engineering part of it. It's still part of the whole structure of the symbiosis of the whole building. It includes all the lights, all the ventilation, all the cameras, everything is the whole technical floor, the green roof, the collecting of water, everything is combined in this roof structure. So instead, what we typically see in structures is that the technical are way too late with coming with their holes and where they're going to do their ventilation shaft and whatnot. So we came then in advance and said, well, these are the whole concept. We can produce these holes to use and these places. Can you work with this? And try and force them to actually come with different scenarios, how this actually was possible to do. So more like a pizza, right? We are the structure, but we still, the structure itself isn't, or the pizza itself isn't good if you not have the toppings, right? So you need to have something that combines and think about the electrical, the HVAC, get the architects, everything together if this is supposed to work. The technical aspect, as you can see on the left-hand side picture, has enormous in this project, and this being a corrosive environment as well, we're trying to reduce the steel as much as possible. So we even did for the whole ventilation systems, we didn't hang them up in the structure with steel. We actually left part of the cutouts, and still being 18 degrees declined, we made the CNC go 18 degrees back again, and with acoustic mat at it, and you can just have all the ventilation just lying, resting in the main structure. So here's a picture of me standing inside. You can see the sheer height of the structure, and you see all the lights for the bathroom and cables and so on. We can't talk about a CLT or timber structure without mentioning fire. And this being a swimming hall, we don't have a fire level for the area over the pool, but around the promenade deck, we have we don't have it as well because of the height from the promenade deck up until the structure. But for the first 9 meters, or the first 2 acoustic elements, we have a F60 rating due to we having a standing or seating area which is quite close to the structure, and this was solved by using both sprinklers and a fire coating of that exact area. So here is a quick look at the structure from the Revit model, and it includes about 3,000 different wood pieces. And you can see that we have a small reduction in height at the very end. You could believe that this is due to the actual, you have a L shape in a concrete wall there with lower span, but this is actually due to a diving pool underneath, and they have like this height requirement for they're not going to jump up into the roof. And quite early on, we actually had like this diamond-shaped thing, as you can see in blue, that we lifted the roof 1 floor up, because then we had a 10-meter diving facility. But as many projects go, we need to cut cost. Hence, this went out and down the drain, and we had all in 1 floor and reduced it by 1 meter. And accompanied a 5-meter diving pool. So it's quite in scale. The structure itself is as tall as a tour bus, as long as 3 tour buses, and it looks like you are like a hobbit when you're standing inside the tallest of it. Structural-wise, it's quite simple. You can look at it as a simple supported beam. You have a steel console in the bottom of the glulam columns along the facade. The glulam column. Then you have a hinge on the top of the column into the beam, and we have a cutout in that beam, and change the grain direction to get better compression strength. And you have a splice in the middle to splice the beam. And the funny story with this is that even though it's being 43 meters, the manufacturer was actually able to manufacture this as 143 meter long beam and transport it until the building site. However, due to the placement of the tower crane, it was unable to lift this at one piece. Hence, we had to introduce the splice in the bottom beam. And into the end at the wall, yes, just like your coat hanger into your wardrobe, you have a steel console on the wall. You basically just hang the structure in, and they're resting and moving back and forth with snow loading on them. Very quickly, the finite element model of the structure, quite complex. It takes about 4 to 5 hours to run. We have about expected 63 millimeters deflection, which is in the middle of the structure. If you look at the longest beam, it's about 70 millimeters expected deflection, which tells you that you actually have quite a lot of effect for the two-way structure from the steel rods as introduced in the acoustic elements. What we also did extensively was adding the effects for all the cutouts and all the different joints of the different elements, which means that the deflection increases about 10% when you are introducing all of these joints. As well as this is a swimming hall facility, it is quite extensive corrosive environment. Timber doesn't corrode, however, the fastenings within the timber might corrode. We did a lot of structure with the Norwegian governing authority, a lot of notes with this. We actually, even though it's a C5 environment, we are allowed to use C4 screws as long as it's within the wood, and we cover up the head of the wood. Instead, we had to use like all these HCR steels and whatnot, and we did a lot of different values on allowable values for moisture during production, montage, and during the actual operation of the structure, including as the red dots here, installing permanent moisture management or moisture detection system. So how should you assemble this? Well, you need a platform, you need a lot of screws, a lot of manpower, and a lot of drills to put all of this together. So quickly through the details. Column to base, very simple steel column. It allows a XYZ directional change of 20 millimeters. And we talked earlier about the beam to column, where you can see the actual hinge, which is milled out of HCR steel. One of these components costs about 4,000 euros. It's the single most expensive component in the whole structure. And you can see we also changed the load, cut out and changed the direction of the grain at the end to get a better compression strength. The joint of the better beam was basically a simple splice beam where we used both screw connection and glue on site, and we used like a self-sealing adhesive so that it wouldn't be any air pockets where you could have moisture stuff in. And this had its process for taking, you have to rub it down, and you have to have a certain temperature, and it need to settle for a certain days and so forth before you could move on. And so it's looked finally. And for the top to the side of the structure, we actually constructed both the bottom beams and the sides to actually be a little bit different than what it actually needed to be, more like a railway track or going cross-country skiing. We had the bottom beam having sides sticking up a little bit, and we have both the top and the bottom of the side plates going a little bit thicker and a little bit down. Basically, you can just use it as track to lock it into place and make sure that it stays on the exact intended place. And of course, the beam to the concrete wall, where you hang the consoles into the wall and you lies and rotates on it. We included a lot of, like, call it IKEA drawings for step by step by step. How you should do it already in the tender documents. Build it on a platform, add the element, talked everything through. You can see here from construction site, you have the platform already constructed. You're hoisting in the first beam, trying to put it into place. And the thing is that every single element were constructed with as close to zero tolerance as possible from the manufacturing, meaning that when the first beam here, the one beam that they are hoisting in now, is in place, that will guide every other element in the whole structure, because you can't take up tolerance anymore. So you spent about 2 weeks on the first beam compared to about 3 days on every other beam after that one. And you can see from the joints of the bottom beam as well. And then talking about what we expected to get compared to what we actually got, We did a lot of work with trying to convince the client, and even had drawings in the tenant documents about this should be built of a roof over a roof system, and had IKEA drawings like this where you have to remove the roof and take it back after you've hoisted in the elements. And we got just basically a PVC thing they just put out of the structure, which literally didn't work. And on the top element, they just put Siga wet guard, which for some, it worked for the intended part, but we had some problems with it, which we can talk about later. And a few pictures for hoisting in the side elements. And then the technical aspects, beam by beam by beam until you were finished. Some pictures from during the construction period. And you have starting on putting all the elements, and you built the platform successive along the way. And hoisted elements and moved containers with screws and everything along the way. So the key thing here, will you always get what you describe? And in my experience, some of the most difficult things you do, you really enjoy being at the site, but you really don't do it as well, because the most dangerous thing you do is you always find something you shouldn't find. So let's talk about the horizontal stiffness of the structure, how you take up the wind load and earthquake loading. This is basically a steel plate from the top of the structure, connected into the top of the concrete wall. Due to the, it's not possible to have like stiffness wall in all possible directions because of the swimming facility underneath. Hence we have like screws here with 45 degrees in different directions. So you actually are taking up horizontal stiffness both on the strong and weak axis of the concrete wall. This screws like are pressing the plate down into the timber and the concrete, and should sliding in an over big hole in the concrete, and work on shear, and it in theory should work really good. However, this happened. This literally just walking on top of the once a week and just looking at something here, this looks funny, and you start to go down and try to pick in it, and suddenly you're standing there with half the screw in your hand, and I was really not good, because as you can see from the drawing in the previous slide, the membrane is supposed to go over this, and then you're going to have the insulation and the green roof. So if I had seen this a week, 2 weeks later, it would never been seen. So you can see here a lot of these screws buckled, and you can actually put both different materials or other stuff underneath. You can see it just wobbles around in the hole, and it's it was really unexpected. And from the left side here, we have to go an extensive round, check every single plate, hold the production on site to see what was wrong with it. And we talked a lot with the manufacturer to see with it, and the actual reason for it is quite interesting. Because of delays in the structure, the main contractor had contracted someone else to do the install of these plates and screws, and they didn't have the proper qualification. They didn't read the manufacturer's guidelines for how to do it. They didn't pilot hole. They didn't use jig for screwing. So everything that could go wrong did go wrong. Hence, there was, instead of doing 45 degrees down, there was like 30 degrees and back forth. So they didn't actually manage to put it straight in, and they didn't even use the moment stop with installing with the right moment key. So we actually had to remove every single screw. That's like close to 5,000 screws, which had to be removed. And since you can't put a screw in the same hole again, you had to basically take every plate back up, move them around. You had to take new holes in the concrete wall, and you had to do new screws and whatnot. Everything because the new contractor didn't fully read the manufacturer's install guidelines. And two, the one we have had the most problem with is the membrane of the structure. So let's look at the membrane again. This is a bitumen-based, fully adhesive membrane on top of the top plate of the CLT, which now, if you remember, is covered with the Siga wet guard from the factory. And then you have the insulation on top of that. So we expected to get a roof over roof. We got just a PVC thing that they rolled over. We expected, as the red one here indicates, that the membrane was supposed to be installed before it arrived on site. Instead, we got the Siga wet guard, and they were supposed to do the installation on site after every plate was installed. So, just before Christmas 2022, I took this picture. It looks good. It looks like it was no sign of leakage, no sign of any issues, but whatever, it looked good. And then I went for Christmas break, 1 week into New Year, and same place looked like this. And you see these air pockets everywhere. You can just basically take your finger, you can start pulling it up. You have water free-flowing underneath it. And it was a mess, to put it lightly. So going inside, you can see that it's just dripping straight through the structure. And there's like this free flow. You have no control of how much water, free flowing straight through. And basically you can see from the details on the right-hand side here, it goes down and to the left and down again. So you have the free flowing water all the way, and it's just not a little bit and it's all over the montage structure, which is within the red area here. And you have two issues, one being the blue and one being the green and brown indicating. The blue one is the stair nose bit, which is the side plates on the whole length of the structure. And the other colors are like butt joints, which takes compression forces, and it just you need to have fully connection between the structure for this to work. And you go straight through, and you even got water leakage straight through. So what we ultimately were concerned about was these details here, because if these fails, you risk the structure falling down. So basically, what happens with the screws, the glue, with the timber? Will it actually work as intended when it's been put through this kind of experience? So the first thing the contractor did was putting a 2x4 on the whole structure, putting a PVC on top of it, and putting a fan on one end, trying to blow it out and starting to try and dry it out. This seemed like a good solution. It didn't work at all. And we started to introduce Mykoteam, which is a Norwegian specialized in moisture detection. And we went on weekly moisture detection on the same spots in this area. The typical wood structure, the wood cell structure in the bottom here, if you have about 12% moisture in it, it's close to nothing, right? And then you have about 30%, you have a little bit the moisture in it. And when you have about 30%, you have free-flowing water between it, and it's fully up. We had in all the red dots here, a lot of those were above 30%. With free-flowing water basically everywhere, and we took out the core sample of it to see, to test them, to see for the capacity and so forth. We talked about, we went to the manufacturer from the middle picture here for the on-site gluing to see and have them testing whether the capacity would still be the same with the swelling and compression, and same with the timber structure. We have had the manufacturer of the timber produce new elements that were sent to the manufacturer of the screws. They were wet up to the same amount, they were screwed in, and they were dried out, and we did tests and whatnot to see if they would still have the same capacity. And I love the fun thing here is that even though you did wet it quite a bit up, the capacity became greater. And this is because the wood swells into the screw, and then it kind of dries away from the screws again. And then we got around probably 10% decrease in the capacity of the screw. And then you have the wood in itself for the butt joints, right? So you have the top plate and straight into each other, and they swell up and trying to move up and start to buckle a little bit on top. And then it will start to shrink and dry a little bit further from each other again, and you risk that being a weak spot for becoming even greater deflection, like you see from this picture. So that was one of our fear. And sadly, some of these greatest, or the biggest cutouts in the structure were just close to one of these top joints, meaning that we also had to look into if we needed to strengthen on top of the wall for the change in the local forces in the structure because of change in the deflection. So after several months, the contractor finally did what we expected them to do quite early on. We got a fully roof over roof of the structure and could finally start a drying out process. We had to manually remove every of the membrane by hand. Poor guy, I'm so happy that was not me. So to remove every single piece. And then we had to build like this drying tents on top of every joint to start drying out the moisture part of it, as well as the joints within the box itself. And of course, you have to go around the damage controls. You can see here, you can see all the top parts. Instead of being straight and nice, you have in the ends of the board, you have swelling, you got this wobbling bit. You're getting a lot of more cracks. Getting from the bottom right-hand picture here, you have the butt joints supposed to work 100% compression in each other. We can see that there's been moisture and swelling. And continued with moisture detection, and we did a lot of work with different membranes and how to make sure that they adhere correctly to the structure, with using primers and different kind of other methods. So let's show you a little bit graph of how long it actually takes to dry out timber. So this is from August 2023 and to half a year into February of 24, you can still see that a lot of these is just samples of a few of the points that was quite wet. The red one is the one that we need to get below. That's the limit of the structure for operational reasons. And the blue is the limit for when you have problems with fungi and other stuff. Of course, you have to have the right temperature and everything with it, but still it takes ages. And this process started about January 2023, so it started half a year before this process, and it's still ongoing today. So it takes quite a long time. So looking back at it, this small incident has caused probably a year and a half plus with drying out of the structure. So you started giving the green light, to put it that way, on different parts of the structure, meaning that you could start to get the membrane on top on removing some of the drying taints and getting the membrane on some parts of the structure, part, and then starting to add the insulation part and then the green roof part, and we were basically left with only the butt joints, because you have very small pockets of water in all the different lamellas down in the butt joints, which is need to work for the structure to work. So how do you dry this out? So basically what we did was we cut out 20 millimeters holes, or about 200 millimeters long, up in the butt joints, after, of course, doing calculation checks to see if this was safe for the compression force, and expecting, well, we do expect to get some more deflection out of this, but this is livable, to put it that way, and building like another drying tent underneath it and try to get air circulated to dry this out and continue to see the moisture in every lamella to dry this out. This worked really well, and then we added a new plate underneath it to strengthen it after the structure of the joint was within the acceptable limits. So moving to the main part of the structure then is the deflection. So from the moment we removed the platform, that was the first time the structure held itself, the whole complete structure. It settled for about 12 millimeters when we let it down. And then we have all the structure. We can see the increase of the deflection from every single time. We did the control about once a month, but you can't put too much into this because you did different work on top of it. You did different green roof, different insulation levels, so the loading was unsymmetric. But you can still see it works kind of nice, but it works a little bit different than what we expected, and that is because of the all the moisture in the butt joints that were expected in the northeast end of the structure, meaning that instead of getting the nice banana shape, you can see that we actually have a 32 millimeter deflection at this period, quite further along to the right here, and it's coincide with where we have the top plate butt joint. You can see you kind of change the whole deflection towards the area where we actually had the moisture and all the leakage problem. So at this period, we actually had a 21% increased deflection compared to what it should have been in the design. And this is for less than a month ago. And then you have starting to become better, but you still see like the blue dot and the blue filled dot should have been on the same space, but you can see the kind of move away from each other to the area of where you actually have had the leakage, and you can see it's a bit a weaker spot in the structure. So how should we actually account for this? Well, currently, there's no point in the Eurocode that account for it, but from the new version, you actually can see that you are gaining like a limit for what's allowable difference in moisture from you start to montage until it's put into use, and actually to make sure that you don't get issues like this. And you also have 2 pages here from the screw book from Rotoblast, which actually gives quite an interesting story about also getting increased forces on screws and fastenings when you have different kind of moisture levels from you starting to put this together compared to when you are finished. And still with all this, it's a huge structure. You will never see any of it while using it. It will not affect the end result. It's from structural engineering's perspective, it's really fascinating. And being a deflection design from the start with, it just means that we had a little bit more deflection than what we should have had. And it's due to open in about 2 months' time, and it looks fantastic. You can see from all the roof structure, we have different part of slides, walkway, bridges, staircase that hangs on top of it. The roof structure itself, fully walkable, accessible as a technical floor. Within it, you can walk to every single part within the structure. You have the swim-in, swim-out facility. You can just lay there down and look at this architectural model piece from it. And yeah, even though everything has been going through for the last couple of years, the result ended good for everyone. So, huge project, 3,000 wooden pieces, close to more than 270,000 screws, and 620 glulam and 1425 cubic of CLT combined into this structure. So, thank you.
Thank you so much, Tim. Any questions from the floor? Kas on küsimusi meil kuulajate seas?
Put up your hand if you have a question.
Can you tell how much was the additional cost for this moisture problem, or it's a percentage to the original cost?
It is currently up for debate between the client and the entrepreneur. So the bill hasn't been settled yet, but the increased cost is, I would say, close to 70% of the original cost.
70% is quite a lot.
Yeah.
So who pays for it?
That's what we're debating about.
Kas on veel küsimusi?
More questions? Wait until the microphone comes to you.
Issues. We currently at least 1.5 years.
Jah, palun järgmine.
Yeah, thank you very much, Tim, for an excellent presentation. And it's unique that you're sharing the hardships and pain of wood. And usually it's never spoken about. So first of all, thank you. And you don't have to actually be concerned, because the diving bridge that you built in Lake Mjosa, that went 10 times over budget. So rest assured. Thank you.
Meil on üks küsimus on siit veel kolmandast reast.
Thank you for the interesting presentation. What I would like to know is, knowing what you know right now, and if you were to design like exactly the same building again, what would you do different?
I would put more effort into the tender documents, to put it that way, because this being a civic building, we have a certain regulation in Norway that we had to follow, and the administration for the municipality was a little bit too heavy for the project, meaning that something got lost during the way. So what we thought and tried to explain was important, it had to go through a certain amount of people, and something was lost on the way. So you needed to put more effort in to make sure that we as engineers, as architects, as actually the whole community for timber, make sure that the documents that comes out, that the entrepreneurs will give price on, actually coincides with what we believe is the right way. That's something that don't get lost on the way.
Jürgen.
Very impressive project, and congratulations. I also have a money question. That you said that in the beginning you did a lot of collaboration with all the organizations and all different manufacturers and universities. And were these people also paid for their work, or did they do it?
No, they were not paid for their work. So basically we did like this. We had a seminar for trying to share timber knowledge, and we baked in 90% our project.
Okay, thank you.
Nii, veel küsimusi? Ja eesireast, Andrus, palun.
I have also a question about the building has the roof out of wood, and you have the swimming pool inside, which means that the environment is quite moist, and it's also aggressive, usually using any kind of ventilation tubes. They have zinc cover, and we know that the living span is short. I assume that you have a strong ventilation in the room, but have you calculated also the possibility that one day the ventilation might be off? And what happens with the moisture then in the air and also in the beams?
We have. And with taking into account the leakage now, we had to remove some slides of other parts of the building that would have covered that. But just to summarize it fairly quickly, the structure itself is really good for the moisture content, because you have a constant temperature, you have a constant moisture level, you will not get shrinkage, you will not get a lot of chlor or that kind of stuff into the wood. And then because you have such a great and good ventilation system, but if the ventilation system should stop, the period is close to 2 weeks before you will even begin to have an issue. So even this is supposed to be operational all year, all day, so it shouldn't be an issue, but in case you need, you will be close to 2 weeks before you'll even start to have an issue. And because of all the fastenings are actually produced or developed with this in mind, so there's not a single screw that is visible. Every screw is within the wood, and the cover is sealed. Everything that's glued, you've used self-sealing glue, meaning that you have no air pockets. So everything of the design has been in mind with reducing the effect of the chlor and everything.
We also have some questions from workshop. So let me quickly read out the first one. Can we conclude that timber construction needs a high professionalism of construction? How to achieve that under tender process where low price tends to be the main deciding factor? How to achieve that?
That's a really, really interesting question, yeah. You need to have knowledge to work with timber. You can't just go to your local tool shop and believe you are then a timber specialist. And a lot of these, it hasn't really been too much of an issue in Norway, at least. And when you come to the new Euro codes, you get the part 3, where you get a lot of different demands in for those who are actually going to do the montage as well. So I believe that the community itself is starting to see this as not an issue, but trying to get like one way of solving it.
I think the second question we got from workshop, I think you answered it. How does the humidity from the pool affect the drying process, or is there an ongoing humidity control? You already explained about ventilation.
So we didn't start. We waited as long as possible to fill the pool with the water. So it dried for close to a year before we filled water into the pool. And then we needed to be certain that we were under a certain limit before we filled it in.
Mm-hmm. And once again, thank you for extremely detailed and exciting experience. How many working hours did you and your team put in this project? And have you went swimming there yet? Probably not, or
it's been open for only. Okay. It's not been open for the public yet. Okay. We have had a few of those for our client. Probably like 5 people have tested the pool, and we are invited to test it in about a month's time.
Mm-hmm. Thank you so much.
Seal on üks küsimus veel.
Vabandust, jaa, võtame ühe veel.
Hi, thanks for a fascinating overview. I was going to ask about weather protection during the building phase, but then you came to that point in the slideshow. Now my question is, would it be possible to visit the place? I'll be in Oslo next week.
You will be able to walk outside the structure. You can probably walk into the reception area and see the structure into the pool. I believe that should be possible. And you can walk all up into the glass facade around it and watch the structure. That should be possible, because it's open to the public now.
One more quick question I see here from the third row. Any other hands up there? No. Okay.
It was already asked, but not answered. Was like how many working hours went into this project?
How many working hours?
I can't say for the team itself, but for me it's been probably like 7,000-8,000.
Well, thank you. This earns an applause.
I just wanted to say that that's the record amount of questions that anybody has ever had in the last 17 years. So thank you very much.
Aitäh, Erik. Meie järgmiseks esinejaks
Thank you, Erik. Our next presenter is Karl-Peter Reinecke, who specializes in sustainability and timber. And he is the managing director of MVPR, that is a real estate agency consultancy office. He studied engineering at the Rosenheim Technical University in Germany, and he has an environmental economics degree from Queen's University in Canada. MVPR is specialized in using mass timber, and Peter has been in charge of Ottawa's mass timber structures. He's also lectured all over the world, and today he will tell us about mass timber optimization, how to make mass timber buildings more cost-effective than concrete. Welcome, Karl-Peter.
Hi everyone. My name is Karl-Peter Reinecke. Thank you for hosting me. Thanks for welcoming me here. This is my first time in Estonia, so it's quite exciting. I've been certainly well taken care of. This is a very fascinating setup with the lights and the smoke. I kind of feel like Beyonce right now, just being up here in front of you. Yeah, Canada and Estonia have a few things in common. We're both Nordic countries with cold climates and a thriving high-tech sector and a very educated populace. And we both have a crazy neighbor. But I'm not going to make any more jokes about Latvia. No, that's fine. So today what I'm going to be talking about is how to make mass timber buildings more cost-effective than concrete. So a big part of my work, what I do is I work with real estate developers. So real estate developers who want to build housing, apartments, condominiums, that sort of thing. And then, so the question always comes up how, if we're going to take a different typology, if we're going to do something that is more sustainable, how can we do this and still get our profits? So in many of these cases, as opposed to the city of Oslo, which Tim just presented on, there are often investors behind the scenes who are curious. Many investors obviously want to make money, but they're often also looking for a competitive advantage. And that's important to say. The other thing that's really important to say is whether we're talking about Canada or USA or Europe or the Baltics or Scandinavia, the biggest real estate market growth is going to be happening in residential real estate. Don't get me wrong, the swimming pool is a fascinating case study. Schools are fascinating case studies. But if we think about the real estate market overall, it's residential. It's the residential sector that's going to grow the most. And so finding how to optimize in that sector, if we're excited about building with wood, if we really want to do more mass timber, that's a major area of growth opportunity. So the background to best practices comes from a national study that we did in Canada. So the president of the Canadian Wood Council came to my company and basically said, okay, we know a lot about fire issues, we know a lot about structural issues and earthquake issues. What we're missing is for mass timber optimization from a broad spectrum management point of view. And so then what we did, it was a very long study. This took over 5 months. And what we did is we interviewed over 60 people, all of whom had deep expertise in mass timber of different kinds. And so by talking to not only architects and engineers, but all the other people, the carpenters, the investors, the fabricators and consultants, we talked to them about their product, all their projects that they did in mass timber, and collectively, these people covered almost 400 mass timber projects across Canada. And so by speaking with all these experts with a lot of experience, I asked them 2 questions in very long-form interviews. I asked them, tell me about your project and what went well. And then also tell me about your project and tell me, what were the challenges, what didn't go so well. So after talking with all these people over a series of weeks and months, what happened was there's a series of patterns which emerged. And these patterns started to tell me a little bit, okay, what makes a project get on time and on a budget, and also, of course, what's going to make it more expensive and what's going to make it delayed, which is what we want to avoid, obviously. That's where the opportunity lies. So that's the context, this that I'm going to be presenting you today. So I'm going to basically go through the key things that drive value and that avoid cost. So the first one is an easy point to make. It's in fact my only slide on this, and there's really not too much to say, except that timber is obviously beautiful. And if you're working with a real estate developer, in my interviews with investors and real estate developers, they basically said, yeah, if you have a nice apartment and it looks like this, you're going to get between 5 and 12% higher lease rates. So basically you now have a product that has more value on the market. So that's a very short point. That's all I need to say about value creation. Landlords love it because they can get higher rent, or a higher letting rate, I think, if I use British English. Site management. I could have had a picture of a crane, but I thought I'd have a picture of a conductor with an orchestra. Because if you've been on these construction sites, it is busy, and sometimes bringing everybody together is quite an ordeal. With mass timber, with a bunch of pieces that are going to be prefabricated, this is where we can control costs. In fact, what's interesting about mass timber is there are often fewer people on a construction site than compared to concrete builds. And pieces are arriving to the site from a fabricator, and then they need to be assembled together. So to make site management work, we have to think about the important questions that get asked. And it's about thinking ahead, and it's about planning ahead. So this is where digital planning, coordination become very important. The truck comes in, is it too close to the crane? How do we keep this dry? Which panel goes first? When is the next truck coming? Where do I park this truck? Et cetera, and do I need to offload in a different spot? What you'll notice is I asked a bunch of questions, I didn't answer them. That's your job. Okay, when you're working with your team, when you're working with your contractors, when you're working with engineers, carpenters, etc., raise the questions, find out the answers yourselves, and think about them ahead of time. So far, a couple of key insights. I didn't want to leave you completely empty-handed on the site management question, but dedicate the crane 100% to the carpenters. There were some case studies where people wanted to move either rebar or other equipment, and there was a competition between, let's say, carpenters and electricians. Once your foundation is done and it's time to erect the mass timber, that crane, make sure that that crane can basically lift pieces non-stop and go as fast as possible to be optimized for total efficiency for that assembly. In fact, what you can do is you can use BIM for this to do a digital practice. You run a digital model and think about the sequence in which things would happen, and that can really help you optimize your site. The big issue that I want to talk about is speed. And I really like this picture, not because I'm a huge F1 fan, but I think the whole concept of how a pit crew takes the wheels on and off or adds fuel to the engine is a really fascinating thing to watch, and it's a wonderful case study of collaboration between different people on a site. One guy lifts the front, other people take the wheels on, wheels off, fast as possible, and I think they're down to 1.7 seconds for the entire car, which is kind of mind-blowing. And speed, I'm going to spend some time on speed, and I'm going to mention efficiency and speed quite often because it is the major issue. Time is money. So this is something, if you want to take out your cameras and take a couple of pictures, this is now we're getting into the real magic of what makes mass timber more cost-effective than concrete. If you're building efficiently, if you have a good system, if you know what you're doing not for schools and free-form architecture where it's very creative and curvy and that sort of thing, but I'm talking now about condominiums, apartments, offices, that sort of thing, where it's a little bit more conventional construction. It's a little bit more rectangular in shape. In those cases, the number that you're looking for is 15 minutes per panel, as an average. Some will be faster, some will be slightly longer, but around that amount of time. And if you're doing that, you're about 30 panels per day. Around something like a 6 to 8 story structure, you're going to be 4 months early. So that's money saved, and that's earnings increased. It's money saved because you're spending less time building, but it's also earnings increased for the developer client because that means that's cash flow they're getting from the letting rates on a monthly basis. So if we take into account this as a chart. In Canada, if you're a construction manager, if you're a developer, you're managing a site, you have basically a ballpark of a monthly burn rate of 150,000 Canadian dollars per month. So if you can be 4 months quicker, you're over $500,000 Canadian dollars. And this is where things get interesting. There was a question earlier about procurement. Some of these procurement issues are often difficult, and often these quoting issues are difficult because mass timber as a product is more expensive. But as a solution, as a bottom line, it's cheaper because you can be done faster. If you have your team well organized for 15 minutes per panel, the whole thing happens faster, and a project that happens more quickly and saves time is a fundamentally more cost-effective solution. Now, I guess that around these numbers, of course, I'm using my Canadian experience. These would have to be converted for, of course, your own context. So if you take that savings in your construction, then what you do need to add is your net operating income per month. My colleague Christoph is here. He'll be presenting a little bit later on. He was actually involved in a project in Canada. It was an 18-story building. It was a student residence in Vancouver. And this is a great case example. 18-story building. The extra cost for mass timber versus concrete was $1 million. Now, why did the client even consider accepting this? $1 million for materials. But here's the kicker, okay? They were done more than a semester early. That's 4 months. And they could have been done faster, but they had other issues because they didn't have dedicated use of the crane, which I mentioned a few slides earlier. But at 4 months earlier, and they had approximately 400 residential units in that building, and at approximately $1,500 per month revenue, in year one, $2.4 million higher in revenue. There's your math. So there's nothing wrong with spending an extra $1 million if you're going to get an extra $2.4 million. And this is exactly the type of calculations that we need to go through as engineers and as planners and as architects to sort of show the business case. Nothing too complicated here. I mean, nobody's drawing in paper, I hope. Everybody's obviously using Revit or some sort of computer software to do their planning. But the key issue is the details. And going beyond low levels of BIM to a higher level of LOD 400, 450, 500, it's at these higher levels. So there's some connection details up there, okay? And it's when we get more specific with this to go beyond even what I'm showing here to add screws and getting to this ultra high degree of specificity, the maximum LOD that you can with all your connection details. This goes very far in terms of getting the specificity that you need from any kind of supplier, any kind of fabricator, and the more detail that you have in all your connections, the better you can get quotes from your installers. So I'll use Tim's recent example with the swimming hall. There, one of the best practices to do is to develop this connection with your carpenters. The carpenters who you know will be doing the installation, because they will have their own ideas about how to maximize the connection. They will have their own ideas about what works and what doesn't work, and that becomes very important for getting efficiency on the job site. Working with a fabricator who can give you exactly the level of detail that you need. Cutting, angles, preparing for brackets, pre-drilling holes. We can do this on CLT panels as well. We can pre-drill pilot holes so the carpenters don't have to take out their measuring tapes and decide how often they need to add a fastener or a screw into each spot. I really like this picture because this is another example of thinking ahead. When you think of your connection details that you develop with your teams of engineers and architects together, talk to the carpenters, come up with something effective, and then go one step further. Look at those connection details. Maybe you're speaking with people from, for instance, Rotoblas about a certain connection detail, and then when you talk to a supplier like Arkwood, have a negotiation where you have these things actually installed in the factory. And so they come to the job site already installed, and you can just imagine how much faster and easier that goes. And then you can probably even get beyond 15 minutes per element. You can probably even get down to 13 or 14. These are all things that accelerate and make everything more simple on the job site. The importance of BIM can't be understated. It's so important to. By the way, are there any? Put up your hand if you're a mechanical engineer. We have no mechanical engineers. This is too bad. We need more mechanical engineers coming to these conferences, talking to architects and structural engineers, because there's more collaboration that we need. In fact, in the world of mass timber, mechanical engineering is very important. If we're already building with mass timber, there's often a pretty strong sustainability profile that the client is looking for, that the client is asking for, and how we think about heating, ventilation, cooling, all our ducting becomes really, really important. And it's really too bad. Finding a good mechanical engineer is always a challenge. It's probably for you as it is for me. I feel mechanical engineers are kind of like panda bears. There's about 7 good ones in the world, but they're not having babies, so it's really challenging. But then with this, you can imagine. So in this diagram, this sort of conveniently uses different colors, and it shows clashing with other pipes. This, of course, can be clashes with beams, floor elements, etc. And we want to surface these as early as we possibly can to maximize the installation time. Because we love to think of timber as prefab. We love to think of the timber elements that I just showed here, right? Like this is all cut and prefab. Well, what you see here, you can do this with pipes. Again, it's too bad that there's no mechanical engineer here, but you can actually do this with all your piping, with all your ducting, and all your ventilation. That can be managed to BIM of 500, the LOD 500. That can also be predetermined, and you can also get a fast install, not just from your timber, but for your entire heating, ventilation, and for your cooling system. So here, what I want to talk about is, again, this is a benefit for you, for me, for our clients. Mass timber lowers risk. Pre-engineered timber systems are precise. Working with BIM and a very high level of LOD, that gives predictability not just for the build, but also for the procurement of all the critical supplies. And the faster assembly means less time before tenant occupancy. So all these factors are excellent reducers of risk. And risk is always a huge issue in the mind of real estate developers. In fact, mass timber is the only building typology that accelerates value during construction while simultaneously lowering risk. So if you're applying the best practices and you're working with mass timber, because we're getting further with mass timber, in most cases, investors, what they're always think of is risk and value as a trade-off. I mean, just think about any time you're looking at investments of stocks versus bonds, this type of thing. Every investment officer is always going to be telling you, well, it's a trade-off, you either have one versus the other. And a lot of developers are thinking in that same kind of financial mindset. But if you're reducing risk, but accelerating value at the same time, you're essentially creating a new paradigm for them to think about. You're giving them a chance to say, I don't know if there's an equivalent expression in Estonian, but there's this wonderful expression in English, to have your cake and to eat it too. Maybe the translators there in the booth can say something creative and supplement my English words. So to sum up this point of full digital planning, it's the BIM plus maximum LOD. The outcomes of this are you're preventing problems and conflicts through early identification. You're getting the best solutions through your team consultations. You're identifying the ideal materials to use for those solutions. And if you take those 3 bullets all together, the result of that is the 4th bullet, which I'm showing here, which is it makes costing easier and it makes quantification easier. Are there any fans here of Ocean's 11, Ocean's 12? These guys are about to go rob a casino. And what I like about this is they're working really effectively as a team. You know, you've got the person with the vision, you've got a con man, you've got maybe you have a getaway driver, you have an explosives expert, and other people there too. But exactly same thing with building construction, you know, your structural engineer, architect, acoustic, fire, etc., and they're all working together. And so when you're doing an integrated design process, don't worry, you can use chairs. You don't have to be standing the whole time like they are here. But the reason I'm bringing up integrated design is because the things that I brought up previously about all these details here, all this stuff, solving all these problems, all of that is made possible when you're running an IDP. This is not optional. You have to do this if you want to realize a fast, efficient, cost-effective mass timber build. You have to bring your team together and you have to sort of work out solutions as an interdisciplinary team. It's what makes it interesting, it's what makes it work, and it's how we as professionals deliver the maximum profit to our clients. So, you have here this lovely bridge, this bridge over nothing, right? There's no water underneath that bridge. That's just somebody put there without clearly thinking about it. And so from this national study that we did, I will share with you 3 examples of people who had so-called project failures. They screwed up their budget or they screwed up their timing significantly enough that it made the client pretty irritated. So I don't know how good your French is, but merde means oh shit in French. And so there was a developer in Montreal. He was very excited about wood. In the province of Quebec, that's where Montreal is, they're big wood producers. That's one of the first major CLT companies in Eastern Canada. And so that developer was very excited to be using wood from Quebec for his project. He had 3 buildings to do. But he was thinking in concrete. He was thinking in concrete and he was building in wood. So if you can imagine doing that and not using BIM, and he didn't think to use BIM for the first 2 buildings, he finally did for the 3rd one. But on the first 2 buildings, because he didn't anticipate all the cutouts and all the penetrations for all the piping and all the tubing and the vents, the structural engineer had to make several trips from the office to the job site, and each time look up at the ceiling, look up at the wall, and make case-by-case calculations. They said the word merde a lot, and they said a lot of other words that I can't repeat here, but suffice it to say that they were really upset and constantly having to rethink, and it's basically a simple problem of not doing proper, fully detailed digital planning, and then having to make decisions on the job site, which slowed everything down and wasted a lot of money. I spoke with one architect on a project in Vancouver early on. I asked him what his project was about, and I asked him if he wanted help. He said, I don't need your help, and I don't need help of other consultants. Trust me, I know what I'm doing. Famous last words. Trust me, I know what I'm doing. He said, there was another project in Vancouver, because Vancouver has a lot of mass timber. That project went well. They used one of the best firms, and one of the best structural engineering firms, and one of the best CLT suppliers. And it was a really good structural engineering firm, and it was a really good supplier. And so he said he has those 2 people, I don't need anything more. And he used that so then he went to his next project. But he didn't talk to carpenters about how to do key details, key fasteners and installations. He didn't feel the need to do that, and he didn't feel the need to talk to any kind of mechanical experts about how to optimize the mechanical system. So instead of that other project, where it was 15 minutes per panel, his project was 33 minutes per panel. It's more than double. So very slow. He didn't know what he was doing. That type of experience is very common. Somebody says, I have one great structural engineer. I've got this guy, Tim from Norway. He's really smart. He knows what he's doing. It's great to have him on board, but you need to have the other people. You need to have a full team. It's the full team that makes it happen. This is another sort of English language reference, Goldilocks and the Three Bears. I wish I knew of an Estonian equivalent of Goldilocks and the Three Bears. This is the story of Goldilocks and the Three Screws. This was a structural engineer who decided to say, I'm going to help your project, and I'm going to think about value engineering, and I'm going to use the shortest screws where possible. And so we had we had 3 days of installing CLT panels. And over the course of these 3 days, it was done in the middle of November in Ottawa, which is colder than it is right now here. And those screws were 280 millimeters, 300 millimeters, and 320 millimeters. Now, if you're building with screws and you're installing things in the middle of a Ottawa November, that's cold. You're wearing thick gloves. And all those screws kind of look about as long as your boot, right? And so what ended up happening is the carpenters, every time they had to install a screw, everybody was always measuring each one or trying to think, and so it became very tedious. So that slowed things down quite a bit. What the engineer should have thought of was just saying, well, why don't you use one standardized screw for everything? And that would have actually saved us money. And it would have been much easier for everybody to not have to think and say, when they have, because they put their screws all in their these carpenters have these pouches on the side of their belts, and they just put them in there. And then if you have a bunch and you need a bunch, you don't want to keep taking them out and taking out your tape measure every 5 minutes and having delays and so on. And so it's a simple detail like that which can have a tremendous impact on how people have speed and efficiency on the job site. In English, we've got a great expression, dogs are a man's best friend. In this case, a dog is a dog's best friend because he's giving him an ACE card. Now, obviously, this is not realistic because dogs don't smoke. But the attitude of collaboration is really important. I want you to think of mass timber not as a product, but as a system. And as a system, it means collaboration. Collaboration means working with people. So if you're excited about mass timber, and I really hope you leave this conference feeling more enthusiastic about mass timber than ever, I want you to think of your next project as an opportunity to create allies and create friends. Think about a design, develop a design, and do what Tim did. I like his example of bringing other people to have a little consultation. Bring people to your office for lunch. Serve them pancakes with maple syrup from Canada, and they will love you, and they will give you your time, and they give you your energy, right? I'm trying to add a little bit of levity and a little bit of humor with showing dogs playing poker, but the principle holds true. If you think of your project as an opportunity to create more linkages with other professionals, if you think about it as an opportunity to create friends within the industry, you're going to learn more. If you have people that you develop a good alliance with, these people will trust you and they will respect you, and they'll give you an honest opinion about what they think that you're doing. And this is how we generate value. This is how we think more productively and more efficiently, and it's how we solve problems and get to better solutions. So, as a quick summary of best practices, I talked about the digital planning with the BIM. I talked about LOD 500, of course, the highest level of detailing that you can possibly do. The timber elements, make them as fully value-added as possible by how they're milled, pre-drilled, membranes pre-installed, etc. Your site management is very important. Your logistics, your moisture management, absolutely essential. Thinking ahead, talking with your planners, talking with the general contractor about how to control for moisture, how to think about all these things in advance and find solutions, not at the time, but well in advance. And then the philosophy is very different. Mass timber is not a product. looks like a product, it's not a product, it's a system. And a system means collaboration, and it means a different way of thinking about how we arrive at our solutions. And it's also about collaboration. That it sounds a little bit too trite, it sounds a little bit too convenient, but this is essentially what we found. I talked with a lot of different people. There's an engineer who has since become a friend of mine. He's an excellent structural engineer. He's originally from Switzerland, then he moved to Canada. And when I interviewed people for my study, I always bought people lunch. I always bought people a drink. That was my thing. I was trying to sort of do that. His name was Bernhard. Bernhard bought me lunch. He wanted to get me on board. And since then, him and I have collaborated a few times, and it's been excellent. And he embodies that idea of collaboration. And even though he's probably one of the smartest guys that I know, he's also one of the first people to give credit for others when projects go well. And this is what I look for myself when I develop my projects. I look to develop teams where there's that attitude of finding solutions, about being efficient, and working together to make it as interesting as we can for ourselves and to deliver the best value to the client that we possibly can. And on the theme of efficiency, I'm actually done 5 minutes early, so trying to live what I'm preaching for you guys. But thank you very much.
Kas meil on küsimusi saalist?
Do we have questions? Erik seems to have one.
For making the long journey here and appreciating our nice climate in Estonia. We pride ourselves in this. I'm thinking you spoke about all the things that go right, but perhaps you could bring forth one example of your experience where things went drastically wrong, even though you planned ahead. What are the things that are perhaps most unexpected that, for instance, with Tim and his excellent example of water at the wrong time at the wrong place, do you have anything that comes to mind that you could illustrate and share with us? Thank you.
I don't know if I have any examples of things going spectacularly wrong, but certainly there's many cases where things have been behind or delayed or just made too complicated. I think the key principle, though, is bringing people on board early and not pushing things down the line. So if it's essentially when people start procrastinating too much with all their technical decisions. That's essentially what shortcuts the project. There have been cases where people design things that are overly detailed or things get over-engineered, and but it's nothing. I feel like I'm not perhaps doing justice to this exact question that you're giving me, but it's nothing that's going to be beyond what you anticipate yourself. So it's having that team on board, it's having that design that's feasible, and by speaking with a supplier in advance, knowing that can be delivered. That's the best way I can answer that. But I don't have a example off my fingertips where things went spectacularly wrong. The project in Montreal was delayed because that was about over $10 per square foot more expensive than it should have been, and that was simply just not using building information modeling and not engaging the trades early on that. That was no integration between the mechanical engineer and the acoustic and the mechanical engineer, stuff like that. But that's. Yeah, I don't know if I'm doing justice to your question.
I have a part two for the question then. Considering the advantages of purely economic gain You would think that real estate developers would be beating your door down. Yet when I visit Canada, I just see a sprinkling of mass timber projects rather than an abundance. So considering the gains, less risk, greater money, less stress, better relationship with your partner at home because you have less stress at work, why is this not gaining greater popularity faster?
That's a great question. Yeah, and that's due to lack of certainty and clarity around price. So what typically happens is that there's real estate developers who are, I'm just going to say it. Are there any real estate developers here? Any? No? Okay. Oh, one. Okay. Well, that's great. So that means I can talk badly about them in front of this crowd. Well, but I mean, seriously, if you have a value-added product that is more sophisticated, that involves more engineering but generates more value, it makes perfect sense that you invest a little bit more time, energy, and money in design development. And so what ends up happening is you have, when you want to do some costing, they're not getting a level of perfect satisfaction and clarity that they're used to. And sometimes I will tell a developer client something like, okay, well, we can get you to the price clarity that you need. We just need to invest a bit of time coordinating design and engineering a little bit and talking to some suppliers. It's like, oh, well, I don't want to pay for that. It's like, well, okay, I mean, like, there's a bit of a catch-22 going on there, and that has to do with essentially the market mindset of people talking to cost surveyors, or sometimes they're referred to as a quantity surveyor, and then not having, somebody says in Toronto, oh, I want to build a mass timber apartment building, and I'm ready to do it. Just show me 27 examples to prove your point, and then we'll start. It's like, oh, well, you don't have 27 examples. Well, that's not good enough for me. So sometimes there's a bit of a psychology in mind with the developer that they expect perfect data, and yet that no data will ever be that perfect if they have that attitude. So that's a bit of the catch-22, so to speak, in terms of starting.
Thank you, Carl-Peter. I have more question. I'm very thankful for your presentation because when architects do the project, then it's rarely the case that the architect does think in the way that how many minutes goes for a workman to finish any operation and the detailness of the screws. My question is that what is the right point for you in the process is to board the project in the sense that one option is that you consult throughout all the phases of the project, or you make your efficiency estimates by getting the detailed design and looking over and saying, oh, hey guys, you didn't consider that. We have like 30,000 screws. Every screw takes, I don't know, 10 seconds, and the sizes don't matter. How do you get your job? I mean, architects go through competitions, but efficiency, it's hard to sell because the client, when you go to the client, how can you say, I will save you $1 million? Is it true or wrong? You don't know. What is the quality of the project? Where do you board the projects?
Okay, so you asked a few questions there. So yeah. I'll start off with your first question. When do I get on board with the project? And usually it's quite early. So in my particular case, what I would do is I would work with a property developer, and I would start off with a feasibility study. You look at their location, you look at what is the business plan for the project, what are the needs and interests, and then based on that, have an idea of what is feasible and appropriate for that location, for that project and its size. And then if I see, encouraging statistics and facts based on that project, then I will encourage that we go forward. And then if I'm involved, I have the benefit of I usually pick my team. So I usually pick designers, architects, engineers, and I assemble that team based on what the requirements that the client gave me. So that was your first question about boarding. I don't know, onboarding. There was follow-ups. I don't know if I'm...
Yeah. But how do you sell to the client the number of efficiency? I mean, how can you say that if the project is efficient enough, or ahead that every project can be made more efficient before the production?
It's basically understanding the level of certainty that they're looking for. So I talked about, very often, if we're getting at 15 minutes per panel or less, I know how to ask that from my designers and engineers and carpenters. I will make that an early goal identified within the team. So it's not just can this be done, but can you do it fast? So as opposed to me asking a general contractor, here's a drawing, how fast can you do it? I will say, I want my panels done in 15 minutes and I want them done really quickly. I want to have over 30 done every day. That forces them to think about how they do it. They might find other carpenters who have experience to get on board. But if they know that I'm asking for it, they will align their thinking and their working to make that happen. Another way to sort of look at the cost feasibility, so we'll look at time issues. I mentioned in my presentation 20%. 30% is not crazy. Sometimes we can be 30% faster than concrete. And then we can look at issues like insurance. The other thing that I always try to do as well when I'm talking with my clients, in the city of Toronto, that's a good example. Some concrete installers are good, some are not so good in terms of precision. And then when you have defects or flaws with how well aligned the concrete has been poured and installed, that creates problems. So if I'm selling a solution, I can also sell my solution as avoiding the problems that concrete would bring. And often developers they just assume concrete is just, they take the problems and the defects and the lack of accuracy of concrete and they sweep it under the rug, which is of course, not fair. And if we ignore flaws in concrete construction, it skews the balance of how we look at the cost of high precision mass timber. So I make sure that gets factored into our analysis about how much time we're saving, how much risk we're managing, et cetera. There's other issues too. Sometimes we can have grants and contributions from different levels of government. Sometimes you can get carbon credits for building in mass timber. So there's a long list of things that you add up, and then you look at scenario 1, scenario 2, concrete versus mass timber, and you make sure you're accounting for all the advantages properly, and then you have a business case to show to the client, and they can decide.
Thank you. Thank you, Carl Peter.
Welcome. Thanks.
Meie järgmiseks esineja.
So our next presenter before the coffee break is Harald Schmidt. Harald is from Germany, and he has a master's degree from Rosenheim, and for the past years he has been working in Switzerland. Harald has received many awards for his designs in different countries, and today his topic is adjusted timber construction methods.
Grüezi wohl.
Yeah, thanks for the introduction, and it's great to be here in Tallinn, in this beautiful town. Quick note to our office: we are based in Basel, in the city center. We are around 20 to 25 people, and we don't just work on timber projects, but we try to work on it when it's possible. That's why we titled it Adjusted Construction Timber Methods, because we think there is possibilities where you have a huge benefit or advantage when you use the material the right way. And I want to start with an office building we designed in St. Gallen, Switzerland. You see here on the right-hand side the old town. Not as pretty as the Tallinn old town, but quite picturesque, with a monastery in the south, and then you see the red square by the artist Pipi Lotirist. And in the middle we have our building gap, where we had to design an office. It was a competition, and the client didn't want a timber building. They didn't expect that. They were quite conservative, but the solution we showed them convinced them. And you can see the block here with the red frame. That was basically the plot. And we tried to fit in that context, very small alleys, very small space around it. And we wanted to keep that street facade. The pink building had to be pulled down. and had to be replaced with a new building, densified, and you can see already the cars going around, there are people walking there in the old town, so it was a dense context, and we wanted to fit in within the surrounding area. We didn't want to do a big show, but we wanted to fit in nicely. And we chose timber because there was not a lot of space left for construction work. As Peter said, the management had to be really, really right. And so what we focused on is that trucks come, drop the material off, and we build the whole project up quite quick. And on the floor plan of the ground floor, you can sense it a little bit already. The concrete work has been done on the 2 stories downstairs. Funny enough, it's not too sustainable because the client demanded 3 lifts. There's 1 lift on the left-hand side, top, for the cars going down, and then 2 lifts for the people using the building. It's a 6-story building. So we tried to keep the core very small and compact in order to gain more office space. Coming back to the ground floor, there is, you can see on the top-hand side, on the right-hand side, the main entrance with a little lobby to wait. And on the left-hand side, there was the demand for a public function, which could be a cafe or anything else. So the public can access that. Going down the next level, you can see the structure we chose. It's like a skeleton building, you can say, in a way, with columns, wooden columns, and beams that carry those columns, not the other way around, and a really strong grid, like no spans longer than 5 meters, very good for wooden constructions, and it offers the client around this compact core a lot of flexibility to arrange the offices. And you can see on the left-hand side, on the top, there is already a dividing wall we put in for private offices. The rest is open space. And as the floor goes up, we had to, by building laws, make the footprint more compact. And the dividing wall goes elsewhere. And you have an open office space, but you still have private corners because it's all wrapping around this central core. And then on the top floor, the building makes another recess as well. And there is a little cafeteria for the people to have their lunch there and go out on the terrace and have a view over St. Gallen. And this way, how the building staggers up, we create this really interesting shape on the side. On the front facade, the earliest picture was quite, I think, a modest design, to fit in with the street space. And then you get this interesting shape that is driven by the building laws. So you have to recess the building to don't have too much shade on the neighboring buildings. This is how the site looked. It's finished already. You can see really quite dense area. We used this the backpack on the back for delivery things, for materials they used. They had to stay there for a longer time. On the other side, there was the whole delivery part for the trucks to drop off the material. And I have a little bit of a more detailed plan, where you can see the core has been originally designed in a prefabricated mass timber as well. And it was an earthquake zone, so we designed a rocking system so the whole building could swing in case of an earthquake. It very often turns out that this is a very good structure and stable structure. But because of cost, it was around 400,000 euros more. We in the end decided to use prefabricated concrete elements that were hollow on the inside, and then there was the concrete being poured on site. But the rocking system kept the same. Next to the core, you can see the columns that hold the timber structure, and there is a little shaft created, and this shaft there is all the pipes and the building technical facilities run up there. It's not a clear timber building, it's a hybrid building. We used a quite clever system for ventilation, and it's a good combination to use a hybrid building, hybrid slabs. And we used these wooden ribs that were glued onto the concrete and then being delivered on site. So there's always, I go back, there's always one element having 2 spans, having 1 rib in the middle, and then they're placed on top of the columns, which you can see here. And the ribs will later on be visible, and already you can see a little bit of technical facilities on the ceiling. And the technical facilities was a demand from the client. You can say almost a little bit unfortunate, because it would also have been good to just use the windows. There's a lot of daylight for ventilation, but the client demanded a climate that is always the same to avoid stress between the employees that work there. And so we cladded in the end these ceilings with the metal sheets. And the metal sheets are slightly perforated, and on top is a thin layer of maybe 2 millimeters of insulation. And this way you get a really nice acoustic in the building. On top of the sheet there is the heating system. There is pipes running along and that heat the building. They activate the concrete, the mass you've got there. And they also cool the building down in summer because the pipes run with cool water then. And the ventilation system blows out the air. You can see slots running along here in the ceiling. That's where the air gets blown out for fresh air for everybody. And it gets sucked back elsewhere. And on the fit out, we wanted to show the structure because the bones that carry everything, the whole building, with all its nuts, the structural timber, and then everything that was fit in, all the cabinet maker work was done in a really fine veneer, in pine, brushed pine, no knots to see really the difference of the different trades. You can see a dividing wall that is really flexible, that can be taken out and put in elsewhere again. And the floor is also an organic floor. It has no statics when you walk over it. It's goat hair. And here you see the top floor with the cafeteria looking out onto the hills of St. Gallen. And coming to the facade, we work a lot with models in our office, and this was a quite strong model that shows the structure of the building on the inside. And we try to be honest on the outside and basically have the strong parts of the building as well on the outside. So it's an imprint of the inside, the outside. And we clad that with, to fulfill the context of St. Gallen, a city made out of stone, clad it with fiber concrete. And St. Gallen was a town, I don't know if anyone has been there. It has a huge history in textiles. There were a lot of textile factories. There's also a famous textile museum there. And we tried to search for references of what the facade pattern could be. And we found this wrinkly dress and searched for references in the past of how we can maybe give these concrete elements texture. And came up with a solution that we give it a wavy, almost corrugated form. And the good thing is it fits within the city of stone. But if you come close, or if you're an architect, you realize it's quite honest. You can see all the tectonics. You can see how the elements are put together. That was important in that case. Here is a little detail of it. You can see the timber column, and it's basically just 3 elements. You have the timber column, you have the windows that fulfill the whole, and then a little bit of insulation and the prefabricated element on top. And this is what it looks like from the backyard. The plinth is in a different color, also to correspond with how most medieval towns are designed. And this is the terrace. The color of the facade, you could see it was this peppermint green. It was not out of fashion. It was, you can see the tiles that have been used there. It's called Ander granite. And you find these rocks, these green rocks, in the rivers that are surrounded in the area. That's why we chose this green. The next project I would like to show is, Peter said before, housing is quite important, so the next 2 projects are going to be housing. And this is the Kunstareal. It was a competition we won. Small-scale apartments and studio spaces, and it was a competition you do together with a contractor. So you have to hand in a project, and you also have to hand in a price. And it makes it very interesting because you save a lot of effort on doing things twice. When you do your tender when you do the design, the tender documents, the contractor comes in, and you've got to do everything again. So in this case, we worked hand in hand with a contractor, one we really like to work with, and made a proposal. The block of land is here. It's in a small town between Zurich and Basel, along the river Aare and Reuss. And it used to be a factory, and the factory was transformed by the client into housing. And they kept some of the buildings, transformed them, they put some new buildings in, and we got the task to build the last block, which is the building with the photovoltaic panels on top, which you can see. And of course, this was the last building before, as you can imagine, there was nothing, and the people really adapted the space and liked it and used it and started to do urban gardening there, and it was unpopular that we built something there. And we said, we do the urban plan in a way that the people still get something back. And we tried to have the axis, you come from the north, that you arrive and you have a little square. An arrival point and also a point where you can meet, which looks like this, a little tree that defines the space. And it's the entrance to the whole Kunstareal, the new entrance. And then we had an in-between presentation during the competition phase. And they wanted to have studios downstairs. And we said, yeah, studios, there's artists going to be working, people doing their pottery. They need a high space. And we worked really lofty, had one story on the ground and then 3 apartment stories. And then the client said, yeah, they really like the floor plans and everything, but we should put another story in. And then we're like, oh man, that's almost impossible. You get a ceiling height we checked the building laws of 2.4 meters, which is really low. And then we started to research what methods could we use to make it feel generous. And having the experience of the Medi-Swiss building in St. Gallen, where we used these ribs, we thought that might be an idea to use that again. So we made this section with the atelier space is still a little bit higher, the studio on the ground floor. But the top floors, they have really a ceiling height of 2.4 meters, but just in the areas where the ribs are. And on top, like in an old building, you always have these areas that go down, so you get a much more generous feeling of space. In construction, it looks like this. We did a very small basement to save costs, and then cantilevered with a floor plate the ground floor, and you can see the system is similar to what we used before. It was also a hybrid system that has been used because then you use also, I forgot to say that before, you have this stretchiness of the timber and the stiffness of the concrete, and it's really quite efficient in terms of costs and also in terms of spans. And then the ground floor, you have 4 apartments on the east and west side. And on the south side, you have a common room where people can meet, because the apartments themselves are just 1-bedroom apartments. And the studios look like this. They were taken really straight away. It's a lot of spaces I think cities need more. There's a studio of a goldsmith here. And how you save costs within a building is always that you make the core very compact and that you reach a lot of apartments on one floor. And the concrete, the core again is in concrete. And we developed this scheme. Another cost-saving point is to have a lot of repetition. So we have this compact core that has access to 6 apartments per floor. And I don't want to say we're lazy, maybe we say we were clever. We designed 2 apartments. We designed the center one, and we designed the corner one, and then we just mirrored them. And then each apartment has different sun aspects. Some people like more the eastern parts, where there is just morning sun. Some prefer the western parts. So the floor plan in the end looks like this, and I'm going to show you the 2 apartments we designed. They're also very simple, very basic. You have a little entrance area, then you have a toilet facility, very compact and small, a storage area, and in the middle you have the bedroom and kitchen, living, dining. The client wanted compact and small apartments in this case, and then the balcony that is a bit more generous, that is just in front of the building. The corner apartment is a bit nicer. It has a very long stretched, the entrance in the bathroom is the same, but it's a very long stretched kitchen, living, dining area with 2 sun or orientation directions and the balcony in front, and then the bedroom, which extends the space a little bit. You can see here what it looks like. With the ribs, you can really feel the height of the floors. And then we, in the end, put in a sliding door that makes the space a bit longer into the bedroom. The facade was also, we just used 2 elements to save costs. We have the horizontal bands that wrap around, that has maybe a little bit of a reference to the existing buildings of the old factories. And then we have the cigar-shaped columns, which were also prefabricated, that carry the balcony. And then it's just filled with corrugated fiber cement boards. And this green and yellow color comes a little bit from the surrounding. You can see it here. The yellow is already on the facade of the existing, has been used in other buildings, and the gray, greenish color comes from the concrete. And we tried to, this is how it fits in. We wanted to have quite a fresh appearance there, almost a Mediterranean touch to it. And we used the columns just where we needed them. So in the entrance that we wanted to have a bit more generous, we put a column there. and very direct. The sun shades are just put in. You can see the fabrics. You can see how they go down. And then this is the main facade. The studs a little bit set in, so you get these open corners. And this yellow color that adds a freshness to it. And the dividing walls, they were always really tricky to design. They very often don't look so nice, where we just used, in this case, we had 2 steel pipes, and in between we just put a sail that was made out of the same color. The next project is a housing project as well. It's in Basel, near Basel. It's a suburb next to Basel. And it was also a competition where we had to hand in a prize. So you have to work really detailed again. You have to really design all the details. Otherwise, when you hand in the prize and then you want to do it later, the contractor says, no, too late, now we're going to do it our way. So we go quite far in that phase. And the city of Basel announced a program that they, until 2032, they want to build 1,000 apartments that are 20% of the rental costs of normal apartments. And this was the first competition where we had the chance to participate, and they asked for timber buildings. And you can see here the block of land. It's on the outskirts of Basel. There is a garden area, the graveyard, and then the border to Germany. And you can see these 2 gray buildings with a gray roof on the bottom. They had to be pulled down, had to be replaced to densify everything. And densifying meaning for those people who lived there, it's quite sad because they had a lot of space. There were kids playing around, they had a lot of garden, they were playing football there. And we thought it's a bit sad as well. So we tried to keep something that they know, and we were really focusing on keeping these big trees that were already standing there for their identification. The urban plan is driven by 2 things. One is these staggered buildings, and one is the staging, which I come later to. And the second is the side lines where you can build on. If you put a whole bar that is just long and not staggered, we would go over the building perimeter. And the second step is the phasing. The client demanded that to avoid stress between the people living there, that the clients could move within the area. So we should build the first house, and then the people move. So in this case, it was house number A that was built. The people move from the house with a pitched roof. The house gets destroyed. Building B gets built, and we do the same again. And then C and D gets built. And then we also had a time frame in this competition. And when we designed, then we said, wow, that's almost impossible to do. It's really, if we have to do this, because you always have to start from, the concrete guys have to come again, the builders have to come again. So it's a really difficult process. In the end, we managed it. And we had a small competition phase, a very short phase of planning, because we could work with the contractor together and develop the details. And then each building was built within a year, very quick. And to fulfill this, we had to go and focus on building with modules, not models. Models we use for the design. Modules. And you can see on the floor plan here of the ground floor already, it's a very stiff, almost design, because you have to think in these modules. They have to be transportable. And that's what shows then later on the floor plan. And you can see the existing trees there, the ones in the center, really beautiful pine tree and a ginkgo tree, and the trees at the entrance. We could keep all trees, but when everything was finished, the tree expert came again, and those 3 trees at the entrance, he said, there's an insect in it, we got to chop them down. So that was really, really sad, because the contractor in the first place said, we can't keep those trees, it's way difficult site management. But in the end, they managed it, and a little insect was responsible for getting rid of 2 of those trees. Then this was all new for us. We had to think in these tubes. And basically, when you explode the floor plan, it looks like this. You always have 2 walls. You always have 2 ceilings. You have everything is being put together on site. And you have the core again in concrete, earthquake zone. So this is the stiffening element of everything. And it's being produced in a factory with the sheets, the panels for the walls and the floor. And then you see in the background already how the modules are being put together. So these are all room cells with all the piping and electricity in it already, with the toilets in, the tiling of the toilets in, We also wanted to have the screed in, but because we wanted to keep the trees, it was too difficult for the crane to carry this heavy weight. So we had to take the screed out, and it was already still 13 tons to be moved, and it was just manageable, but then the rest had to be done on site. The idea was to do everything, put the parquet floor in, and then just plug it together and put a border over it, and you're done. But that was the theory that didn't work. And then designing in modules, the factory was not too far away. It was maybe 20 minutes by truck. It's also a task, if you build, let's say the modules would come to Tallinn, you have to think really far ahead, because then certain sizes don't work anymore. And in this case, the crucial point was this corner down there, how the truck goes around there. So the contractor has to think really far if all this works. And the modules in the end had a x-axis measurement of 3.85 meters. And then again, to save costs, we had to hand in a prize for this competition. We used the excavation of the existing building and put our basement in there, very small basement. Then we built the floor plate, and then we put the modules on top of it. And the people living there, or especially the children, I think it was a very nice construction process. The site first looks very, very strange always when you build this big core and the building wraps around it then. But when the modules come, the kids could watch how their new apartment is being delivered and being stacked on top of each other. And it goes quite quick. It's like within, the first building was built within a week. The longer buildings, we needed a week per floor. So building A is finished, building B gets destroyed. And building B, I want to say a little bit about the floor plans, because there's also a lot of repetition in it. We designed 3 elements. We designed the western and south type, which you can see on the left-hand side. We designed on the right-hand side, which is the main part, where you access through I don't know the English word, but the German word is quite nice. It's called a Laubengang. You walk along to access your apartment. Also very efficient with just one core. And you enter in the kitchen dining area, and then a little offset you have the private living area. So you have people can see in the kitchen and dining area, but they can't see the living area, so you still have a little bit of privacy there. And then in between you have always the compact facilities for the showers and bathrooms. And then you have on the left-hand side, I already said, they're mainly 4.5 to 3.5 apartments, just a few 2.5s. And we had this Laubengang, which is also cost efficient, but it's also a really nice element, a social element where people can meet. And it's crucial because they can meet and they also create noise, and some people are annoyed by it. That's why we said the entrances, we offset them a little bit, so you have a little private area where you can walk in. And the same we did it's the north side now. Well, you can see the north sign here. So it's the west side for the balconies, loggias for privacy that are being put in between those modules. And the Laubengang tended out to be a real activator for them. There's a lot of different nations living there, and they really meet there. The kids throw the balls down and throw them up again. They get into trouble with the parents. The people meet there when they come from work. And it's really activated, and you can see when you walk if someone is sitting down there at this little square with the old trees, and they gather there and have their baklava and their tea and their mocha, and it really activated the whole block. On the inside, you have always a little bit of a see-through. We wanted to be quite honest, so you see the joint of the modules on the ceiling. Very nice when you design a wooden building or when you design modules, you always get a wooden ceiling for free. That's part of it. And an architectural detail is also this gap you have on the roof, which we architects quite like. But it was also for free because the contractor said when we transport the modules, they move a little bit. So they needed some space for these expansions. Then here you can see the view through the apartment. We added for sun shading textiles to make everything a little bit softer. Then was the focus on the facade, where we also didn't use a lot of difficult elements, but it's mainly driven by the protection of the wood. So we have a very large roof that protects the wood from the weather. And to carry this roof, we have the columns that make this little significant curvy cutout. So that carries the roof, and then these columns also carry the balconies and this Laubengang, this way where you walk to the apartments. And then always you have horizontal areas, the slabs in between that define a little bit the spaces, because it was, or the surface, because what we didn't want is that the people live in containers. Like we are now, all the speakers are in this nice container hotel, which is nice. But if you live there permanently, we didn't want to have this appearance of living in these modules. We wanted to clad it a little bit and use these elements to do so. Construction-wise, the elements come together like this on the left-hand side. You see the floor plate out of concrete, and then the first module comes. There's just a 5 centimeter CLT ceiling, and then the next module comes. The slab of the modules is always I don't know the English term, it's a Hohlkasten. It's hollow inside. And then there's rocks or pebbles for weight, for acoustic reasons, and then the normal floor build-up. And when these columns are being put together, the modules are put together, then the column comes on top, and you can see on the roof you have this little beam that spans to carry the roof across the different columns. So it's a very simple system, a board that runs horizontal, that covers the slabs. And on the facade where the balconies and the Laubengang is, it's also, we wanted to work here really direct. And with not a lot of maintenance, so we decided to have, as we used in the project before, prefabricated concrete elements for the balconies that are just resting on metal angles. And so they're really robust, you don't have a lot of worries with them, and they're very thin in the design, which is something we quite like there. Then here you can see a picture of the facade, how the Laubengang, how this corner opens up, and how the space is designed. Inside, you always have views through the buildings and get a greater idea of space, of outside space. The existing trees could be kept. And the color concept, I think as a northern country, you're quite familiar with these colors. They have a big tradition in Sweden. And they also have, they're very durable. And I want to be honest, there we quite like this color, but we also had another option, which was a green color. And we thought the red is really pushing the space, it might be too much. And in the end, we consulted a color expert on that, and she said, yeah, it could both work. In the end, we liked it because it is a nice contrast also to the greenery around. But the color was chosen in the end by the client. We said, you have these two colors, what do you prefer? And then one was a fan of Scandinavia, and they really liked this color and chose it in the end. And yeah, we're quite happy with it. That's the last image. Thank you for the attention.
Now, do you have questions for Harald? Yes, please. A microphone? Could we have a microphone?
Hello, my name is Martin Varvas from Lumber Lab. I wanted to ask about the floor structures of the first two examples that you gave, and how did you deal with acoustics? I understand you had glulam beams, and then you poured concrete on top of it, so it was working as a composite.
Yeah.
But how did you achieve the required acoustics there?
Yeah, I didn't show this detail. That's a normal floor build-up which we use in Switzerland, or I think in most countries a lot. You have a layer of insulation on top, and then the screed, like this little concrete layer that is no steel in it, and then the carpet on top of it. It's not just the slab itself and you put the carpet on, that wouldn't work, especially with a client like that.
Thank you. And then we have a question from Works Up, which is about your role as both an architect and an engineer. The question is about the situation Germany and in Switzerland, but also the question poses that also in Hungary, that you can join or unite both the job of an architect with that of an engineer. That do you need to be extra talented, or what is the situation in that case? Because here in Estonia it's quite a separate set of jobs, and then it's not so. It doesn't even seem reachable to unite those. It seems as if it's what you're doing is in space or something.
Yeah. I think it's not very typical in Switzerland either. I think normally you have the architect and you work together with the engineer. But if you design in wood, I think you have to think a lot about the construction, because the wood is always the detail, it's the spans. Concrete has no end. You just pour it and it goes everywhere. And wood has a certain distance. Even the swimming pool had a certain distance you could reach. So you have to think a little bit more structural, I think, and this maybe comes with experience. But then also you just choose the right. In Switzerland, we're lucky enough to have a lot of really good timber engineers, and they assist you with your ideas.
Well, thank you. Any other questions? I see your hand up there. Erik, please.
Yes, thank you very much for a great presentation. I'm just curious that how would you assess the last decade? In Estonia, we're having a kind of a revitalization of timber building just now in the last 5 years. Have you noticed this same situation, or have you been consistently building with wood, or is it gaining popularity amongst architects, engineers, and builders and developers in Switzerland? Thank you.
It's a good question. Everybody always wants to build in wood until they see the price. Then they turn around and say, we build conventionally. A lot of competitions are, especially the ones that are done by the state, they explicitly say, we want to have a timber building, we want to have a sustainable building. So you go this way automatically. And these competitions have been on the rise, I think. For clients that are coming from a private sector, it's a little bit harder. You have to convince them. You have to do a lot of work. You have to focus on that you build quicker, that you have a different climate in the building. But there is a drive this direction. There's also a bit of a drive in Switzerland of reusing material. So this whole climate debate is all coming into a big, it's getting a swing now. Yeah.
Any other questions? Well, once again, big thank you, Harald, for such an inspiring lecture. So thank you.
Thank you.
We have time to stretch our legs. We only have, 30 minutes. So could I please have you back? 3:35. Thank you.
Yeah. Jätkame konverentsiga.
We will continue with the last section of our conference. So our next presenter is Ad Kil. He's from the Netherlands, and Ro and Ad architects for 20 years has had the focus of making the world a more sustainable and fun place. So in addition to fun buildings, they have tried to integrate the buildings into ecosystems. So they study restorative design and the reuse of timber, which is slightly unusual. And today, Ad will tell us about regenerative architecture and how to enlarge your green footprint.
Good afternoon, everyone. Thanks for staying. That's nice. Huh? It's been a long day already. I'm going to tell a little bit about our office. We are with a few people who do really nice projects, I think. And we do things like this, the Moses Bridge, one of our most known projects. Watchtowers, all in timber. We do a lot of watchtowers like this. This is also a watchtower, all in Holland. Sometimes we do a house, and sometimes we do a school, like this. So you see, we work a lot in timber. This is a birdwatch we did 2 years ago. Some of you went to watch it a few weeks ago. It's really nice as well. But I'm going to elaborate a little bit more about 2 other recent projects. But first, I want to talk about sustainability. When we talk about sustainability, normally you talk about reducing the footprint, reducing CO2, reducing your presence. And the less you are there, the better you are for the environment. So when you're dead, you're the best for the environment. And then we don't believe in that. It's an irritating system. We like to think in big green footprints. So every step you take, something grows out of it. And that can be nature, that can be culture, or that can be economy, or that can be socially. So that's the goal. So really regenerative design. So if you see this graph, the normal sustainability is about doing less bad, is below the line. And if you make something that adds to the environment, then you're starting to be regenerative. And that's difficult. We don't reach that level yet, but we try. The one who tries best is this guy. This is an oak tree. And an oak tree is not about reducing its footprint. An oak tree is about getting as big as possible, sucking sunlight in, producing 100,000 seeds a year, and it only needs one to reproduce itself in its life. But those 100,000 seeds in the system takes care of about 1,200 to 1,300 other species, fungus, insects, birds, boar, things like that. So this is actually the goal, to make a building like an oak tree. But that's a goal far away. And there's another thing. We always talk about nature and people, but there's no thing as nature. Nature is an imaginary concept. We are nature. We are really part of our environment, and we should act, as architects, we should act like that. First project, Energy House. Delta Wind, these are the people of Delta Wind. I show them because they're really important. They're really important because they help us to make the building better. And Delta Wind is a very specific company because it's a corporation, which means that all of the members, they produce energy with windmills, and all of the members really have a say in the company. So they have 2,600 members. So we got this commission to make this new office for them, and every decision has to be made by the members. So every time we had a design, we had to call up all those members who wanted to come, and they had to vote for if the design was good enough, if the money was good enough, if the contractor was good enough. So we had there was a really special client. And they all live on this island in Holland, and all of the wind they produce is also produced on the island for their clients. So they really have their own energy system. And there are things like this. This is their... They bought a piece of land, which was a very poor piece of land, very low in biodiversity, very dirty water, full of shit from the farmers. And we wanted to make it like this. That was the first idea. We wanted to make it rich, with clean water, lots of biodiversity, flowers, and local biodiversity in the water as well. So what we first did is make an idea for the landscape. So we scooped up half of the land, threw it to the other side. So we made soft lines in the water, like this. And then we placed the building on top of those hills, those little hills we made. This creates lots of little ecosystems in the garden for biodiversity. Another thing is that the buildings behind it were quite ugly, so we wanted to cover them up by lifting the building and putting it in front. So this is the landscape section. We scooped out the sand, made a nice garden, and put in a building like this, which is really narrow as we could make it. And the size of the building is exact 4 meters, because 4 meters is just big enough to place a table, place two chairs behind it, and walk around it. So that's the main section of the building. And then, of course, we wanted sunlight, solar panels, light from the north, and we added a greenhouse, but I'll come to that later. And then all additional functions like storage, workplaces, things like that, entrances we placed at the back. So this was the first design we had. And then came the phase where we had to go and build it. So we collected all those knowledge, like Peter said earlier. So we collected a contractor, installation guy, of course the client, and a BIM modeler, and all of those people, and we did a team day. Just before we started to work on the building, we did a team day where we did really games to see how everyone would react and to prepare ourselves to the upcoming task, which we know, all of you know, that it's not easy to make a building, especially not a building if it's a little bit different than others. We wanted to build a circular building and a bio-based building as far as we could go. And therefore, you need a really, really good BIM model. We had Chris. Chris was our BIM modeler, and we asked all of the parties who joined the building to add to this BIM model, so we could really we could reduce all of the failures who would occur. So that results in drawings like this. And in the building process, these are the drawings we used for the permits. But in the building process, we didn't use any drawings. We only used the BIM model on the side. And so no details, no plans, just a 3D model. And there was a really cool device. So they scanned this QR code, and then you walked onto the building site, and you can really see what had to be there. So that was really cool, especially for the people, for the plumbing and stuff, to see what they had to make. Yeah, here is the plan. You can see the 4 meters with the tables in the middle, and the workspaces and all of the things at the back who were just stacked on the building for these extra spaces like entrance and toilets. Second floor. So these were the plans, and then we had to build it, of course. And how did we do that? The foundation is a ring of concrete because it's really wet in the ground. We couldn't do it here with wood. You place columns on it, which is azobe, which is these were reclaimed wood. So there were all second-hand mooring poles. They were drawn out of the sea, then shaved, and then used as an under construction because it's really tough wood, which can be used outside, and it's really strong as well. So you only need very relatively small diameters. A floor, we also made 2 concrete, what we call cellars, above the ground, but they call cellars. One for the battery, because it's a self-containing building, so we needed a big battery, and one for the installations. A CLT as a tabletop, where we could put up the glue lamp in pine. From Maren Melhoff, we went to visit there, also as a part of the process to have the team together, and we took home those beams. Yeah, this is an interesting one. Halfway, when I'm not sure if you have that here, but when we reach the highest point of the building, we do a little celebration in Holland. And we did it here as well. And what we did is we went fishing for mussels. And we did that, the client and the contractor. And we cooked a meal for all of the people who worked on the site of mussels. And that really also worked as a glue into the process. So you could really meet the people and talk to them when you got there. That really worked. Well, the floor is also of a CLT, and the entrance also of CLT. This is the circular azobe, which is really drawn out of very close near the side. We use that for the poles, but also for the other structural elements. Timber frame facades with it's called nano CLT, just for stability also. And pine for the rest of the interior, like the frames inside. The outside, we clad it in the outer layer of those mooring posts. So those mooring posts are shaved. 2 centimeters to 3 centimeters is sawn off. And we use that for the facade to clad the building with. And you can really see it. If you look closer, you can really see the shells still sitting on the outside. There's a part of the facades which is not which is behind a greenhouse, and there we used local larch because it didn't need that really good azobe material because it doesn't get wet. So that's this picture. And then for the windows, we used the thermally modified fraqué because we didn't want any paint in the building, because paint is always chemical. what kind of paint you use, it's always, and you have to maintain it every few years. So we wanted the windows which you didn't have to paint. Wood fiber insulation, of course, and beech for the staircases. So these are all the types of wood we used in the building. Solar panels on the south, way more than we needed. So it could deliver to other people as well, and glass on the north for the light. Installations, what you see a lot in the Netherlands is the middle picture, where you just put a lot of insulation into a building just to get the temperature to 21 degrees all the time. We didn't want that. We wanted a system with. We went with the mechanical installation guy. So how can we make this building happen without any installations? And of course that's not possible, but we minimized it. And one of the things we added was a greenhouse on the south, where we with plants in it. So the plants in the greenhouse, they lose the leaves in the winter. So in the winter, the sun comes in and shines inside. It warms up the greenhouse, and the building looks at the temperature in the greenhouse and decides if they use the air in the greenhouse to use as ventilation air or as heating. So it's quite simple, a quite simple system. It's a standard greenhouse with single layer of glass, but it really works. Yeah, we have some very tiny patches of flat roofs, but we decided to, even if the area was only like 10 centimeters, like here, this is not fully grown. We used green roofs, because where we can help nature, we have to do it. And then we added some housing for sparrows, blue tits, blackbirds and bats. And also a house for a barn owl. And the funny thing is, we during construction we made this house for the barn owl. And during construction, within a week, the owl was in it. So he found it. I was really glad for that. This is the garden. The garden is also made up full of recycled materials. So this is the end result. From a few weeks ago, the garden still has to be made. Some pictures inside. Yeah, this is a staircase where you can pull out a tribune to have presentations. Yeah, this is a nice one. We also looked at other than the building materials. For example, the toilets. Normally, you make them out of porcelain. But that's made with a lot of heat, and you can't recycle it. So we chose for stainless steel, because you can really recycle that. Also. Yes, just some images. Curtains for keeping out the sun, and for acoustics. The greenhouse. In the area. Next project, the Hedwigepolder. Hedwigepolder is a polder in the Netherlands, which is quite big. And here you see a part of the Netherlands. In the south there, the city where you see this is Antwerp, so that's Belgium. And Belgium has a big harbor. And the boats go through this river to the harbor. But that's Dutch territory. But because the boats are getting bigger, and ships like that come in there. And so they have to deepen out the river every time to keep those boats coming in. And as nature compensation, because it's Dutch territory, they decided to give up this polder, so to give it back to the sea. And there was a lot of resistance, so this polder. And there was a lot of resistance, it's in Dutch, you can't read it, but there was a lot of resistance from the local people. So they asked us the first task we had is, how can we make those people happy that we give those polder to the sea? How can we make them happy in the future? So we made this map. We did, I think, 150 interviews with local farmers, with communities, with the harbor of Antwerp. And we came up with this map where we drawn up all the chances that are in the area when the polder is when the polder is given back. And from these interviews, there came a group of people who became enthusiastic about the idea of this. And this doesn't work, I think. It should be a movie. Okay. So well, I'm going to explain. One of the things we did is when you give a polder back to the sea, you have to remove all the dikes. And the plan was to get rid of the dikes, get them of all the soil, get it in a ship and dump it somewhere. But you said, no, we want to keep it in the area and then make a hill and give this hill to the local people to exploit and for people to see the nature that will be there. So that was this image. And this is the image where they started to clean the polder. A lot of poplars were there. And we said, well, we keep them. We keep them for future buildings in the area. So we store them with a local farmer for maybe things like this. And then came the harbor, and they said, well, if you're going to make a hill with a building, maybe we can use it as well, because we need a new radar for the harbor to guide the boats safely. And can we integrate that in your building? And that was a present, of course, because that give this building, which didn't really have a function at that moment, give some weight. And then we redesigned it to this building where we had a restaurant and a top floor with a viewing platform, a nature education center, and some eco lodges where you could stay, full of on top of this hill, that hill. And it should look like this. And these are the drawings that are made now, and it will be constructed. Construction will start in spring. But that was, and the hill is already almost finished. You can see it. That was this image when I got this. When we sit in the office and you make all these dikes from clay, and then you put them together and you on a little hill, and you present that to the client, and then 3 or 4 years later, because it's a long process, you see this. That was really surprising for me that they're really going to make it. And you can see here that the polder already has gone, so the dike has gone. Other things that came out of this map full of chances was was all of these spots. What you see is during the time Holland raised the dikes, they were 100 years ago they were like 3 to 4 meters, and nowadays they are 9 to 10 meters. So what you have is that you, from land, you have no connection to the sea at all. So one of the things that came out of this map is that all of these villages that are placed there, they wanted to have a connection to the sea again. So we made this is work in progress and not finished yet. So we made all these connections from these little villages with stairs to the sea, so they could enjoy the view of the sea again. We made some pavilions on the dikes. And another thing that came up was a local nature reserve party, and they had always had this area, which is the drowned land of Saftingen, which is one of the most beautiful nature areas of Holland. It floods about twice a month, and it has a really rich population of birds. And in former times, and at that place, this nature preservation organization wanted a bird research center. And we found out that in former times, like 100 years ago, there was this. This was a shed for sheep, and it was built with driftwood. So the people with the sheep, they just stay there and they found some driftwood and they build a little bit more. And we thought, well, that's a nice theme. Can we use that as a theme for this new building? This was the building they had, which was okay, but it was really rotten, so it had to go. And these are the birds that are there. There's a lot of, these are actually pictures of the people who work there. And they ring the birds there, that's what they do, and they count them. There's also foxes, of course, which are not so good for the birds. And there's also a certain amount of very special bees that are only occur at this place. They're really almost extinct. These are these. And we thought, well, you have this really beautiful nature area, and you have these people who want to be there. How can we make a house for both of them? So we made this principal section where the red part is for the people, and all of the other parts are for the animals. So the underside, the roof, the facades, the attic, it's all for the birds and the bees and the plants. We used the same mooring posts as well, but also for the foundation here. It was a really task because the longest one, which you see here, they had to be 18 meters to have enough, to go deep enough in the soil to hold it. And another task we had was we had a really small window of building because we couldn't build in the breeding season, which is from February till the end of August. But we couldn't, because it's the sea, we couldn't build in the storm season as well, which is from the 1st of October to the end of March. So we only had officially 1 month a year to build. We extended that to 2 months, so we could start building in half of August to half of October. So it took 3 years to build this. 3 years of 2 months. This is a reclaimed staircase, which we used as a floor table to make the rest of the construction of it. We insulated the people part with straw. And these are normal wood elements, timber frame elements. The underside of the building is made of old tabletops. And all of the window frames are also made out of reused wood, which looked really beautiful. but is in retrospective was not a very good idea, because if you reclaim the wood, you can't really tell what it is sometimes. So, and if you mix and match it, it goes wringen. It just opens and it goes wrong. Here are building phase. Here we did experiments with the facade to see what we could accommodate on plants and animals. So we did some tests, for example, for the bees with this stuff. We did some tests for amphibious animals and for spiders. The attic we let open. Of course, we made a house for the owl as well. And here, the same story, not in a week, but in 2 weeks. During construction, the owl was back. And it's a challenging area to work in, because you see there's a lot of tide, so now it's low tide, but in high tide, and especially in spring tide, then the water will be around 20 to 30 centimeters under the bottom. We use the trees of the Hedwige, which I showed before, to clad the inside of the building. And the poles of the Hedwige we used for the bees. They drilled lots of volunteers drilled holes in it, and we used it for the bees in the facade. This is the terrace. And what you actually see is that during construction, you see some experiments with the clay for the bees. During construction, it was already occupied by the animals. These were eggs from a falcon, dove, and then we used the same principle. This building was built earlier than the last one, so here we did some experiment with a greenhouse as well, but then without the plants, as a climate facade. So we used an old second-hand roof of a greenhouse in this hallway, which connects all the rooms and functions as to capture the heat. Very low tech. There's no installation here at all, except for this and a few infrared panels. And here you see in the summer when the heat is too much, there's this hatches, and then you open them, and then the heat disperses through the attic. The roof has a very low inclination. That is every project we seek for an ecologist to see what we can do. And he said, well, you can have this slanted roof, but it has to be really flat, because otherwise the eggs of the birds, they roll off, so and they won't nest there. And it's really intensely used, because this is the only spot in the area where they can lay their eggs and breed, and the fox can't come there. So it's really busy on the roof in spring. This is a fake one, huh? The owl's back. Flies in there. All kind of birds already occupy it. Here the mud for the bees, and above that for this, I think they're called sparrows. Bats on the attic as well. Bees in the wood. Spiders in the stones. And that's it. 200 slides.
Thank you so much, Ad, for such a beautiful and empathetic, inspirational lecture.
Thank you.
Do we have questions from the audience? Kas meil on küsimusi kellelgi? Nii. Workshopi keskkonnas on meil tulnud paar küsimust. So we have some questions that have come in through workshop.
Okay.
And one is, for instance, that first of all, a very interesting topic and approach. Thank you. Are there any other sustainable energy solutions besides green room and solar panels that you used or considered for cooling, humidity, or winter ventilation?
In the first project, I think?
I guess it's...
Yeah, in the first project was about minimizing the insulation. So we thought about ice cellars, storing heat in stone, everything, but that all comes with lots of pipes and engineering and installations. So we ultimately decided to go minimum. But of course, there's lots of other options, but we didn't choose that for this one.
Well, thank you. Then there is a question about the Moses Bridge.
Yeah.
That what is the lifespan? How long is the lifespan of that bridge?
Oh, we did that in 2010. It's now 2014. I've been there 2 weeks ago, and it still looks good. It needs a new foil on the outside. So I think lifespan is at least 25 years. Yeah. But it's made out of akoya, which is a very inert treated wood.
Mm-hmm.
Yeah.
Wow.
Yeah.
Then another question. If you intentionally draw birds so close to human walking areas, how do you prevent the birds attacking people while nesting, as it is their natural instinct towards humans who are a threat?
Yeah. Attacking is not a problem. What a problem is at the last project I showed. You saw all the holes for the. I'm not sure I think it's the sparrows that there is the bird shit. There were a lot of them. There are like hundreds of them. All of the nests were occupied, and half of the building was white. So that you have to accept if you do that kind of stuff. Yeah.
I guess so. And then there is a question about a house in the middle of a sea island, next to a highway and windmills. Was there something like this in your slide?
A house?
But I guess the question is about, is it not a dangerous location for wildlife? I guess being near windmills. Perhaps this refers to the Delta Wind project.
Yeah, the subject of windmills and birds dying is one of that occurs. What happens, for example, with Delta Wind, the energy company I talked about, they have now installed like radars on their windmills. So if a bird of certain bigness occurs, then the windmill will stop. So but there's what you see is there's been a research of a local nature organization in Holland, and the biodiversity around windmills is actually in birds is bigger than anywhere else because there's birds flying against those. They die, and they attract other birds of prey. And so the biodiversity is bigger around those windmills. But yeah, it could be a problem, yes. Yeah.
Well, thank you. Oh, one more question. What is the square meter price of the bridge, the Moses?
The Moses Bridge, it was really cheap.
Yeah.
Yeah, I think the square meter price it's 50 meters long, it's 1 meter wide. I think the total price was 200,000 euros. So it was not very, very expensive.
Mm-hmm. Any other questions from the audience? Aha, we see a hand here. Microphone approaching.
Hi, my name is Laura. A fascinating variety of different woods used. From Estonia, where do you get these woods and different species of timber to use for different applications if you want to make it a reuse other than ordering it from Brazil or something?
Yeah. We have a very good connection in Holland with a contractor who just buys all this second-hand wood and gets them out of harbors, and he has an enormous pile of thousands and thousands of cubic meters of second-hand wood. So we order it there.
Any other questions? If not, thank you again, Art.
Okay, thank you.
Ja meie viimane tänane esineja enne auhinnagalat.
Now comes our last speaker. It's Christoph Dünser from Austria, and he has been working as an architect for 35 years, and much of his work is connected with research to test the boundaries of the profession, working a lot with different hypotheses they set up, and to prove the possibilities through real projects. And one of his interests is traditional handicrafts and joining these traditional approaches with conventional building. And the topic for today's presentation is constant revolution or evolution, as you like it.
So first of all, Eric, a big thank you to you and the team for having me and for hosting us yesterday. It was a pleasure. Thank you. So I start with my lecture, constant revolution, meaning all we do is evolution, not revolution. Sometimes the outcome of one or the other evolution turned to be a little bit revolutionary or new in the world, but that's what we do. In 2015, Herman Kaufmann asked in the office, is there anyone willing to be part of the leading team? And because if I retire on university, I'm not going to go put that effort, that time back in the office, and I need some young people to go along with me. And I was one of the three that raised their hands, and so we founded Rahvusvaheline, I think in 2017, as we did. And that's the team. It's about 27 people around. And we're based in Austria. It's next to Switzerland, Germany, and Liechtenstein, one of the best places in the world. That's the Lake of Constance. And we're based at the dot in the Google. And that's our office. A very good argument, and it's about my own agenda, still looking for people maybe interested. I have two more very good arguments. This is 30 minutes away from the office and plus climb, and 15 minutes the other way around. There's a Lake of Constance, so a very good area to live. Does anyone has been at the convention in 2015 in the room? No one? Yeah, sure. There are a few. They presented the ICT-1. We just delivered it. It was an 8-story building, a building system, and it's more or less what Carl Peters said before. It's not replacing a material by wood. It's the whole process. It's a whole team. It's a whole thing. How do you can possibly deliver a building to the site? And we just were on the way to deliver the UBC Vancouver building, which is an 80-story student home. And at that particular time, I did not know that they contracted the facade to a different, by a tender, by a reason, I don't really know. If you see in the LCD one, the column is fixed on the facade, so the facade is never laid. The idea is the facade of the building should protect the building while building up. This little detail helped us to a lot of problems at the beginning of the erection. If the film start, look at the right-hand side, we asked them to be just one level below with the facade, and as they start, you can see they're late, they're already late. 4 levels have been built, heavy rain poured in, and we had like problems of delamination or not. We had to test it. After that, they went very well, and they built it up pretty fast. The UBC Vancouver is like 14,000 square meters delivered in 9.5 weeks, and you could even do faster if you do involve more prefabrication. And the reason for that is like seen on the left-hand side, weather is changing, and all these wooden constructions are very sensitive to water. I'm going to show you today a very untypical project for our office. It's for the industry, a big facility. It's the Schraubenwerk Geisbach, SWG. Maybe you know the name, but you know the product. It's the acid producer from Würth. And so far, this was the plant they had already. All the different buildings belong to them. And we promoted them a little bit with the FT connector. We had a project together, and I joked on them, you make a lot of money from carpenters, you don't have a single wooden building. So this is the site from above, and as they want a new production line for the long timber screw, they ask us to do additional building to the plant to show off the capability of the long timber screw, and as well as showing a lighthouse project to show off whatever they are able to do. So they ask us for this, doing an appendix. And Alois Wimmer is not known for spending a lot of money on architecture. And if you think about on the right-hand side, we should have an addition to have like an architectural lighthouse project to promote the new screw. So that was what we came up with. So the first reaction was, whoa, that's too big. So we told them, you can have this size. So it's a very classical plant. On the left-hand side, all the material comes in. Then in the main nave, there is the production, and on the upper and lower side, all these technical facilities are needed. In the end, there's a heating oven, which is very frequent, and the dimensions are quite big. The span is 41 or 40 meters. And the client asked us to just highlight whatever the screw is able to. He has an own engineer for that. See the lever through. And that's the main section. So we have like two big trusses spanning 41 and 40 meters. And on the other hand, we have like these truss bridges visible, letting in the light. That was the idea, to have a building that lets in the light for the production, to have like a nice facility for people to work with. That's from the outside. The client asked us to do whatever is possible to show off the capability of wooden construction and at least the screws. So you see there's 4 towers, and on the front end side you see this is a suspended floor, 10 meters. Then you have these 4 bridges, 40 meters to the columns. And all the stiffening and bracing for horizontal stiffening was very complicated to do because there were only those 4 towers delivering the forces to the ground. So SVG, the Henning Ernst, the engineer of WG, did a very well job on delivering all these details. It was very complicated. Everything is done in beech veneer wood, which was about the first time at that size done. That's a look at it, and you see if it's a very transparent look. All the forces go into just these 4 towers. All the horizontal forces go into the towers. There's no concrete in them. It's just wood. The main truss, if you go for that span, would mean 4 meter high, and it's 2 times 24 to 56 if you go in spruce. It's like 64 cubic meters and 32 tons. If you compare that to steel, that would have been these members. And if you go to beech veneer wood, you can go under these limits. So look at some of the knots of the building. It's the main knot. How can you possibly transfer these enormous powers with a very classical detail, which is a notch? If you have like a notch connection, it will be around 1,000 Newton, but that's not sufficient for that kind of construction. So you need to have a multi-notch connection, not weakening the upper cord that much. So you can deliver 2,000 kilonewtons. If you have like an extended version of the notch connection, you can deliver 3,300. Needed was 2,000, and that's the detail for the main knot on the truss. The center knot was far bigger. It's called the puzzle knot. It's the top of the column, then it's the lower chords. There's a block on the lower chords. 4 more blocks. They deliver the forces of the diagonals to the column without compressing the chords. Then there's this fork of the vertical member, delivers the loads directly to the column without compressing the lower chords. That's the forces that happen to be on the knot, and that's 2.5 meganewton on the main column. No one has really an idea what about how much is that. And if you take 2.5 meganewton on a column, that's an Airbus 380 on one column size. And a full takeoff weight of an Airbus 380 with 575 tons on 2 columns. It was very difficult to mill it because the milling machines are not designed to have that loads. So very complicated milling. We had to do a lot of tests to reach the accuracy of the knots. This is a model for one of the nodes for a stress test to see the accuracy is not good enough. So eventually shim plate or reorganize the machinery. As Tim said before, it's a real problem. You have to do all the things in the shop because you're clean. You see there's a drilling on site, drilling in the shop. We had like to have the right angle. We had a device to guide the drillers. There's special drillers for beech veneer wood. A lot of screws here is a screw maker. And every screw was protocoled. And so you end up with almost like a piece like furniture. It's a very big truss, 4 meters long. And even the secondary truss, which spans 18.6 meters, we could use beech veneer wood with a very complicated knot design, very beautiful parts were assembled, pre-assembled and brought to the site. So this is the site. We asked the carpenter to do just one tower and then go up with the infill to the top and put the roof on. But he went horizontally. There you see the suspended floor, 10 meter span with a connection detail, very complicated. We asked the carpenter to do the facade of the bridge on the ground to have the protection, the weather protection. He went for these membranes, which turned out to be like a big problem during the process because there were heavy winds and they destroyed the membranes every once in a while. Lift them up was not a big problem. And you see that like the one problem, this is the secondary trusses arriving on site. They're unpacked, beautiful pieces just brought in place. And the problem is that the roof makers are not able to follow the carpenters. The speed of the carpenters is enormous. So you need to have like a very good weather concept. See them struggling to protect all the beech veneer wood that is very sensitive to water. There you can see that's the delivery port for the facility, almost done. And this is the first view where you can see like all the construction done, and this open to the east side, all the forces go down to the towers. The main node and the secondary node. The bad weather concept that this particular case for the beach veneer wood was painting, to have like the lignous seal paint on top of it, but that's not sufficient. This is just in case of emergency. So that looks, if it gets wet, and it's just for a short time. But you can even see here that a part of the beach veneer wood swells a little bit. It's not a problem, it's not delamination, but you see that's just after erection phase, it starts to gain a little bit of a problem. And that's what's happened. It's not the beautiful daylight photos, it's the weather that was on site. It was raining, heavily raining, real big beach veneer trusses outside exposed, not a good thing to see. You see, we did, in the RCT1, we did a grouting, a water dense grouting for the timber hybrid slabs. They didn't do, so they had to sand all of the beams there. See, we have water on places you don't want to see water. Thanks to Tim, that another one shows pictures of something running in the wrong direction. In the end, it turned out not to be a big problem, but you can see that's something that you want to do better next time. See the facility, and after they unpacked, we could see almost a catastrophe. Again, we had to look at these points. Is there delamination? Do we have full capacity of these knots? It turned out to be okay, but it's something that I do not want to see anymore. So we have to prepare better for bad weather situations, because if these projects get that big, it might occur these problems. In the end, this is one of the first F19B walls in load-taking, horizontal stiffening walls in Germany. That size was done the first time. And you see there's a big machinery inside, like it's even a fire, the hardening oven is not a problem in a wooden environment. So there's no excuse not to do it. It's doable. For the pavilion, which is the office part of it, or small office part of it, we had to reduce the amount of wood to use, and we went for a thermal actuated timber hybrid construction, which is screwed with a FT connector. There you see the thermal actuation, the blue pipes and the gray ones give way for the screws. A very simple concrete part, it's the best thing they can produce. And then you can see on site, a very clean site, very fast montage. But again, shit happens. And that was you face normally on site. Everyone telling you, he erected a building, even that small, in a good weather season, that's a joke. It's not true. It's going to happen. You have to sand all these surfaces if you don't do it properly. If you don't have any weather concept, you're just related to the luck, and you won't have that luck. For sure, that happens. For the interior extension, we could convince the client to take Austrian cabinet makers in joint venture with a German one, and it starts to get the material. We're used to be like kind of like an Amazon society. We just order. We do not care where does it come from. I'm a son of a carpenter, and so it's very important. This is spruce that normally go to the veneer industry. And that's how the milling is done. There's something that almost vanishes away, because the way you mill it will predict how it will perform. Will a lathe turn or not? Depends on the direction of the earrings, and you want to have like upstanding earrings. So you have to have a plan how to mill it and prefabricate it and bring it to the site. It's very important just not to order things, to think where they, but to think where they come from. What does it consist of? So we ended up with a hybrid building. All the members here that you see in concrete supposed to be in beech veneer wood, but it wasn't doable because Pullmeyer could produce that amount at that time. So we had to change to concrete, but I think it's a nice combination of materials here. Very well done. We could convince the client to use his brand color just inside the staircase, not outside. That's the bridge to the facility. And from the outside, Reinhard will personally ask us to do a metal sheeting, and that's the way it looks like from the perspective of the pavilion. And this is an industrial building, an approach to architecture to show off, like it's possible that industrial buildings do not hurt the eye. I think it's very well done. That's the side. They can just add the same volume to the other side to be functioning. Every once in a while, you got the chance to do something that is outstanding just because of the site, and that is the site. It's unbelievable. It's one of the first bigger mountains in Germany, and on the corner to Austria. And the best thing that you normally don't have in Austria, you don't have all the panorama of the Swiss and Austrian Alps. If you're in the Alps, you're just surrounded by, you don't have that view. So this is remarkable. And that was the situation we found when we came there. It's like on the left-hand side, you can see the old ropeway, then it replaced it by a new ropeway, and the building in the middle was a restaurant, and behind the restaurant there was like the peak. You couldn't see the peak from the valley anymore because you just can see that beautiful building. There were concepts how to use all what is all around here, but there was no way to reuse it. So we went to tear everything down and start a new thing. And the idea was the restaurant goes to the left, and the ropeway just gets a new housing, and the view to the peak, towards the peak, is supposed to be free again. For that particular project, we went into a different kind of thing. What we really do is everything is curved. And the terraces are curved, the glass is curved, and that caused kind of a total different kind of details and ways to construct it than we normally do. It was very complicated. Even load-bearing curved CLT you can have if you order that, if the client will pay for it. It's not cheap, but it's doable. And it shows even rounded shapes are not a big problem for wooden construction. It's just the way of building with a helicopter is kind of like a weird thing, because we found out the hard way why it's Nebelhorn. Nebelhorn means in German foggy peak. So you just have a few days where there's no fog, the helicopter can fly, and there's not enough wind. So you have to deliver very, very fast. So you can see all these round-shaped things done for the first time in the office, and it was kind of a pain in the ass that you're not able to shift around the element. It's very complicated to do that. But in the end, there's a lot of craftsmen that supported us, like with a very gifted carpenter who used to work in that height, which is very important, but because it's a total different setting. And in the end, we ended up with like a project that had triple layer glasses, curved, railings curved. You see the view, it's amazing. If you have a beer up there, it's like a good thing to do. We convinced the client to do also the interior extension in wood. So he had triple layer sliding doors that can stand 100-kilometer wind speed, which is enormous. From the inside, everything is done in beech, in ash, massive wood. We want to have like not the typical tourist project we see in the Alps. It's supposed to be architecture. It was a very hard discussion with the client, and in the end, we succeeded and could do a modern view with very vulnerable surfaces. They were afraid that people are gonna destroy them with their ski boots and the kids with their helmets and stuff like that. But we learned with the years that people tend to not harm vulnerable surfaces because they got to know it's vulnerable. I'm gonna destroy it, and no one wants to destroy it. So it's in a very good shape. And I think after 3 years, the building that cost 7 million euros was paid by just of the turnover. We could convince the client to have like ovens with handmade tiles, and which is enormous, expensive, but kind of that's for the people. They come here to see the mountains. Why giving them a surrounding that is disgusting and just done, or just has the idea of undestroyable, everything's steel or stuff like that. And you can do funny things today with all the methods to measure distances, so you can do round shapes, very complicated things, just prefabricate them down there, fly them up, and they fit up there. It's a beautiful thing to do, and see all these details coming together, planned and produced in the valley, and then flown up and brought to the places. And in the end, the client told us, there's one big problem. They close down the restaurants at 5 o'clock in the evening, and they can't get the people out. So that people try to stay as long as possible to see the sunset and whatever. So it's a very good point for them. They have a lot of people coming up. I just recently saw that they take 87 euros to get up there, and there's a line waiting to get up. So it pays off eventually. And now in the last 15 minutes, I show you I think as long as I've been in the office, I was working for that project. This kind of like one magic place. Just without our work, it is a magic place. And we have the fun to be there since the, I think, mid-90s, and still renovate and convert some parts of it. So I'm going to tour you through 3 different phases of the reconstruction of the building. That's the main building. It's a former monastery. It's not a monastery anymore. It's more or less a hotel. And these are the 3 things that I want to point out. Like the first phase was the yellow part. We got a contract in December 2013. We got permission, or application was like in March. Permission was in June, and we started the day we got permission. An impossible speed. And we asked the client, please, don't do that again with us. And he did. Phase 2, same principle. We got the contract like again in December, application in March, permission in June, and we started. For the phase 3, we started voluntarily to do the basic design in 270. We got the contract in 2022. The application was before the contract, and we started permission before the contract, and we started build before the contract. That shows the mutual trust you can have to a very good client. So to construction phase 1, it's more or less, I can just show you the roof thing, because the roof thing is the wooden part of it. As you can see, very old building. The main section shows like everything is from 1682. And the fascinating thing about that is that roof. That roof was in perfect condition. Nothing was rotten. Just the 4 roofs we had to replace. All the load-bearing structure was in perfect shape. So we just built everything on top, the joints. So it's not in between, it's on top. So you don't have the vapor barrier going through the construction, so it's outside. And as we removed the 4 roofs, we could fold down the vapor barrier at the end of the construction. which is the best way to do. Then we got rid of everything they put in in the 70s and built all the rooms needed for a modern restaurant into the ground in the cellar. It was a very spectacular sight. And then, very untypical for us, this is the beginning of a timber hybrid slab. So all the members were delivered through that door, brought to the place. It's 24 centimeters in height and just 8 meters span. I'm not a structural engineer, but I would say that without a concrete, that's sufficient. Then we put iron on top of it, put concrete on top of it. Very frustrating. We got this 8 meter span ceiling by a load of material, which is very unsustainable. Sustainability is all about reducing the materials. So we promised next phase, we're going to do better. Next phase, the roof was from the 70s, so we removed it mainly and used the members that left here to shift the construction. And we went for a weather protection system again, and had the day of construction, we started to lay out timber concrete hybrid slabs. It was one of the first Meyer-Mellenhof sites that did. The fascinating, again, 8 meters of span. That's, I guess, 14 centimeters of wood and 10 centimeters of concrete, and you have all sound and all fire protection issues behind you. Full span, just deliver it to the site, load it down, and erect the construction on top of it. So you have a very fast building process, which is very natural to nowadays. And you end up with a project like very woody, even if there's just the kitchen is outside, the only new volume we built in. And we could do a lot of things. The floor you can see was made of one tree, just one piece, uncut 8 meters, just one tree. There's a lot of ash that grows next door, and we could convince the client to mill it ourselves, just to cut the trees, cut them to the milling, dry them down, and then deliver it to the cabinet makers and have all the interiors like done in massive wood. So you end up with like a very touchy thing, and that's the main room. That's the old load-bearing structure, a very beautiful room with all the windows in. It's like a little bit like small, like Auchan, we have all these lights coming in. It's a fantastic room. And that's the hotel part, the wooden part of it. Again, built up in ash, and again, is a very good thing. Inspired by that thing that the roofs are so perfect, we thought that if the stable has a roof that it could go on for such a long time without getting destroyed, we faced the main building, so for renovation. And this is before renovation. In the 70s, it looked like that. So at that particular corner, we put in the additional security staircase without destroying anything historical. And again, the roofs. We're not the first ones to do that. So you see the purlin of the first rough construction, and above there's a second one. The problem with that kind of things is, one time they started to heat all these buildings, and all the members of wood that go far out to the facade have one tendency, and they look like that. And you need a film to just get it. It's all humus, it's all gone. So we were humbling and saying, what the hell? The stable is perfect and the main building has these problems. So we had to get rid of all of the thing, and we have to leave the beams inside, because underneath there were historic ceilings we couldn't or were not allowed to remove. There was gypsum and there was wood, and so we had to do another complicated hybrid system. This is the diagonal construction between the beams of the historic one. We removed the clay, then brought in some iron, so we had like an old wood connected to iron and then CLT hybrid thing that going on to have fire protection, to have the extension on top of it. The roof was always cut in the 70s, so we were allowed to get rid of it. There you see the removal of the roof, and with a flyby, you can see that on top of it we have again a newly construction method. We used the CLT because we need the two-way span capability of the CLT, and with the super fast erection phase, you see all the materials loaded into the garden to brought in place very fast, because everything underneath is not only wood, is very sensitive to water. So we needed to close the roofs very fast. So CLT was, and boxes for the roofs were the right solution for that particular part. Again, in the 70s, they put in a roof, and that roof was so narrow to the roof construction nearby that the roof, if you imagine in winter there's loads of snow, they built the roof to prevent the snow from falling down into the yard and ruin the walls there. They put a roof on top of it, the glass roof, and so the snow lies on top of the roof and starts to ruin the historic roof trusses. So we had the idea to remove that and put on an extra level to have more place for the roof, to have like all this connection to the historic roofs. You see, like there's like a flat roof in between the historic roof and the new glass roof, to have like a chance to let members of the historic roofs to survive. I show you one room, which is called the Prelate room. It's the state room. It's the most important room in the monastery. And there were a lot of things going on, and we had to restore the oven. We had to redo the cladding, and everyone telling that in former times that all the carpenters did it the right way. Look at where the oven is standing. There's 3 floor constructions above the beams, and the very heavy oven stands next to the beam and starts to fall into the room. It just had an angle. So we had to support all the construction, bring that in to the outside. We had to restore the details of the wood panels. We come from 1640, I guess. We had a restoration cabinet maker, which was an amazing guy. He restored everything. He added all the things that they cut off for new windows that was done, and carved new details. And in the end, we had to cover these places, these radiators, and we wanted to do that in wood, and we were looking for in the office very long. How can we possibly do that? And on one chimney, I found that pattern. You see that squares over there, and really newly we got a laser printer, a laser cutter in the office, and I asked one in the office to cut the pattern out of the laser cutter, and to convince the client with a sample. We need money to get an eye on if there's a laser cutter who's able to do 2 centimeters of wood, massive wood, and there are. So we could cut that pattern out of an ash plate. So we end up with that. And the same guy who restored all the historic thing did the cutting of all the things. It's one piece with a Japanese saw by hand, which was freaking to see. And you hardly can put a hair between the old and new construction. Nothing is aligned. And after all the treatment of the new parts, so it vanished a little bit away into the historic construction is not more important than the other ones. So I think a very good solution was very funny to do. And as we are doing that, this is the reception, and the reception is in front of the entrance part, and we didn't want to put a door to have like a fire protection to the thing, so we did a lid on top of the reception, and if the reception is closed, you're just going to wind down the lid, and the reception is closed. So we couldn't do a lot of details that you normally are not allowed to do for a client, which is amazing. We got a lot of detail work inside. Everything is done in ash, and with an eye of detail. We could convince Martin Rauch, which is a relative of mine, to do the rammed earth floors. That's, by the way, the most important staircase goes to the wine cellar. And that's the main room. All around is the raised yard. And the client was very afraid about the acoustics in that room. And once in the night, the Accor appeared there for the first time, and you see in the window, you can see the client, and he has goosebumps, and just texted me, "Oh, the acoustic is perfect. It's very well done." We did nothing, just to, if you do something without any acoustical things, only the trusses for the glass have acoustical dampers inside, and everything else had to be added. So we asked the client, if you have to add it, let's finish first, do the test, and if it's not sufficient, we're going to add something for the acoustics, but we're not perfect. The same thing you can do with wood, you can do with steel. It's just oiled steel, the radiators underneath, and then there's the ramp floor earth. And everything is again done in ash. Staircase is also done, it's folded steel in just oiled and brought into place. Welded on site is a perfect work. It's just a piece of amazing quality. And this is the main floor with the rooms and the new doors. Some impression. This is the top of, there's maisonettes on top of it, and always done in ash. Nice rooms to be there. There's 3 rooms that are bedrooms in the roof. One of the historic roof trusses, which are not any longer load-bearing, but still very beautiful and conserved for the back time. And it's very important that we care about these old constructions, because it's also very sustainable to keep them alive. It's very important to look at conversions, and that's from the outside. And as I know that you might remember just 3 or 4 things from that lecture, for the Screwmaker Factory, we have published a book with all the reports and numbers and figures in. And we got the present from detail to be mentioned as a monography of all the things we had to, of all the projects they had in their papers. And last but not least, it would be a nice place. Thank you for your attention.
Thank you. Christoph? Kas saalist on tekkinud küsimusi?
Are there any questions to Christoph?
Ma näen, Erik Konsel on jälle käsi püsti.
Hello, thank you, Christoph, and thank you for coming. One question, are you still doing, because you began your presentation with an advertisement for unemployed architects, I'm just going to inquire if you're still doing your music festival at the monastery.
Yeah, we're still doing it. It's, again, something that we are not only the architects, we're part of the team that's hosting crossover festival of young classical and young jazz talents there, and everyone want to come by. It's likely to be next year again.
That was free advertising, by the way.
Yeah, sure. Thank you.
Ei paista rohkem küsimusi. Täname Kristoffit. Thank you.
Seems that we have no more questions. Thank you, Christoph.
Tantsin siis laudade peal. Tere õhtust! Mul on suur au, et ma...
Good evening. It is my great pleasure to sing. My name is Mari. So the main character of the conference is wood and the beauty that can be created out of wood. I like trees, forests, wood. I like to take walks in forests. I always dreamed that my home has a lot of trees that it is surrounded by. And I always believed that if you cut a tree down, you can create something very beautiful and long-lasting. 3 years ago, our family built a house. It's a wooden house, a log house. It's a beautiful house, and I hope that it will last for eternity. Thank you for creating this beauty. And here are a couple of more songs.
Kusagil veel käib pidu, öö juba ennustab valgust. Ma kohendan kirjutet ridu ja ootan millegi algust. Ja ootan millegi algust. Kusagil keegi peab pulma, mina poen üksinda telki. Kõiges on elu ja surma, all tähtede igavest helki, all tähtede igavest helki. Kusagil on minu lapsed, kihutan pilvedest läbi. Murul on õisi ja kastet, mööduvad päevad ja häbi, mööduvad päevad ja häbi. La 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 la. La 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 la. Kusagil keegi loob laulu, mida ehk lauldagi sünnib. Kilomeetrite kaudu teeb endale päevad ja tunnid, teeb endale päevad ja tunnid. Kusagil keegi seab tiibu enesel viimaseks lennuks. Hää võta vastu ja liibu, et süda ei kiruks, ei vannuks, et süda ei kiruks, ei vannuks. Kusagil jõutakse koju, sinna, kus ladvad ja juured. Usu mu väikene poju, sind ootavad rännud veel suured, sind ootavad rännud veel suured, sind ootavad rännud veel suured. La 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 la. La 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 la. La 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 la. La 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 la. La 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 la. La la. Tule tutvusta end, miks sa longid mul järel. Lihtsalt niisama keset novembrikuud. Õues on külm, no kuhu sa lähed? Kui ammu sul pehkib küljeluu. Su kole kirjupale ja kustunud tähed ilmuvad öös keset novembri. novembrikuud. Tule tutvusta end, ära istu mul pähe, ära täida mu silmi ja suud. Mida loodad sa veel, kas ikka on vähe? Õues on külm keset novembrikuud. Kuni kestab see öö, sa vist ära ei lähe. Tule tutvusta end, juba raaguvad puud. Aitäh!
Suur tänu.
Thank you to Mari Jürjens for her lovely music and songs. So we have reached the main part of our evening. Many of you have been excitedly waiting for this. So we are starting our gala part of the Wood Architecture Award ceremony. So for 22 times we have awarded the best of the best wood structures in Estonia, and this year the jury's job was also quite difficult because there were so many nominees as previously. We're very pleased to see that wood as a construction material is something that our architects like to visualize. So on the screen, while listening to the songs, you saw the nominees. 29 buildings, from sheds to apartment houses, port facilities, summer homes were presented. The jury had difficulty how to choose between small-scale, large-scale buildings. They just cannot be compared. So it was difficult to choose, but it is proof that wood can be used for buildings with different functions, different sizes, and you can do it innovatively. So the jury consisted of Mari Rass from Architect Must, and as you know, Architect Must won the award last year. Maarja Kask from the Estonian Association of Architects, Reijo Raudsepp from the Association of the Interior Architects, Mart Karm from the Academy of Arts, rector, Andres Madalik, engineer, and then Elar Vilt who represented Woodhouse Estonia. And we first give the award to from the Estply wooden interiors. So there's an Estonian proverb that the shirt is very close to the body and wood is very close to us in the interior. So when wood is close to us, we see its benefits as opposed to concrete or glass or steel. And it feels good when you touch it, when you walk on it. It's beautiful to look at. Wood has been irreplaceable throughout our human civilization. So we will see where wood has got to over the thousands of years. So the Estply interior nominees are the screen, the summer house and the Rae school. So Estply's special prize is worth 1,500 euros, and the award will be presented to the winner by the CEO of Estply, Timo Hermlin. Could we ask you on stage, please? Good evening. Estply Interior Award is for a minimalist, detailed, convincing interior, characteristic house in a house solution. The summer house in Rannaküla. Architects, contractors, clients, Tomomi Hayashi, Anna Henriksson, Hayashi Groschmidt Architect Studio. Interior architects Mari Hunt and Tomomi Hayashi. Engineers Mihkel Sagar, Main House Oy and Timbecko Woodhouse Oy. Timbecko Woodhouse Oy, who built the house. Perhaps we would like to ask you to stay in the auditorium, because after the gala we will take photographs. So all nominees, could we please ask you to remain here as our photographer is on the way. The next prize is the Rightwood Planed Material Award. So whilst constructing, wood has sort of had a minor role. People always demonstrate their position through stone, concrete and steel, and wood is used more in rural areas, but now times have changed and planed material has become a trendsetter, and who you look at, walk on, touch, because more and more, instead of concrete, we use natural wood. Planed wood can also boast by being used by billionaires. On facades and public buildings, the Rightwood Planed Wood nominees are Põllu 63 Health Center, Kuusalu School Building, and Dirhami Nature Resort. For planed wood, Rightwood has put a price of 5,000 euros, and we would like to give Ivar Dembrovski the floor to give out the award. Ladies and gentlemen, before I open this envelope, I had an idea that just occurred to me. I think, or I'd like to think, that this is a compliment to everything that has been done, that from Herman Kaufmann Architects, we hear the announcement that Estonian architects come and work for us. So thank you, Christoph, for that. So Right Wood, Plain Wood prize goes for a building that fits into the environment and is complete and has used plain wood to the Dirham Nature Resort. We'd like to ask on stage the engineers, architects, clients, Marju Hunt, Helmi Langsepp, Marju Hunt Architects, Viivika Tihkan, Marju Hunt, Angelika Torn, Marko Uibo Interior Architects, engineer, Peeter Stumbur, contractor, Dirhami Nature Resort.
Pildistamine on hiljem.
We'll just like to remind you that we'll take photos then a little later.
Järgmisena
Arkwood Glulam Award. So, as it seems that we don't seem to fit onto this planet, all of us who are conservatives, vegans, meat eaters, liberals, we all have different opinions. But Glulam is as if the different sides of the magnet that draw each other. But the world that has cracks won't stand. So it's the last moment for the mankind to glue itself together. Climate change, wars, all the social media platforms, they have the same effect on us. And we can only cope with these effects together. So just like Glulam, which stands strong, bearing the winds and storms. So the Arkwood Glulam nominees are the Kalevi Yachting Club House, Rae Gymnasium, and the Tuule Sports Building. Arkwood has proposed a special prize of 1,500 euros, and the award will be presented by Arkwork CEO Peter Peedomaa. Please come on stage. It's my great honor to say that the Glulam Award is to be awarded to the building where the central part is the ballroom, which uses Glulam and CLT in a smart way and in a complex way. So Glulam is visible and dominant. And the winner is Tuule Sports Building. We'd like, again, everyone on stage, Laivo Kotov, Coco Architects, Interior Architects, Raili Palling, Kadri Kaldam, Liisi Lindberg, Coco Architects, Engineer Tom Marula, PCC Project, and the contractor Randan Tuulberg, client Rae Local Municipality.
No, pole. Suur tänu, kallid sõbrad.
Thank you and congratulations.
Delfi, moodne kodu.
Delfi, moodne kodu, people's choice. The border is often very thin, what people like and what they don't, what the elite likes and what the common people like, so we don't have to decide whether a pop band prevails over the symphony orchestra. But here and now, we give the award to what people think, so people's choice. And Delfi, the online newspaper, moodne kodu, people's choice, will get the annual package to read this online paper, and the award is presented by Anni Martin, who organizes the whole award ceremony and competition. On behalf of Delfi, I'm very glad to hand out the People's Choice Award. So there were 2,500 votes that were cast, and as always, the competition was very tight. And the best was a building that has received its name after Lembitu Kuuse, who was a sports commentator who passed away. Kuuse elamusmajad Kõrvemaal.
Ehitaja ja tellija. Arhitektideks.
Architects, POA Architects, Interior Architects and Engineering Projektibüroo OÜ, Contractor, Pinered Ehitus, Client, Kõrvemaa puhkekeskus. But the jury has also some prizes, because sometimes there are nominees that don't come into the top 3, but they basically stand out, like the best dancer at a singing competition or something, or someone that makes you feel good or makes you think. So in addition to the prizes that have already been awarded, we also had some sort of special nominees that we'd like to mention. They will be then receiving special awards by Mari Rass, who was the head of the jury. Good evening. So the 2 nominees, I'd like to point out, they discussed the same topic. They had an environmentally friendly approach. They found practical solutions and raised awareness. So reusing materials, the Ava shed. Architect and builder, so these are the students of the Art Academy. Elina Liiva, Helena Männa, Margus Tammik, engineer Andres Lehtla. And then for reusing old materials, we'd like to give the award to the Tartu bike sheds. Architects, engineers, Roland Saks, Prilli Saader, Riinu Soodenpits, TalTech students. Simo Ilomets, Targo Kalamees, Uniro Group, contractor, and Tartu City Council, who was the client. And another special award goes to a building where the jury said that it's honest, economic use of wood, both in the interior, in the exterior, and load-bearing structure. And we also would like to point out the community aspect, the environmentally sustainable aspect, and enriching the urban society, the Logi sauna. We'd like to invite architects Kaisa Sööt, Liina-Liis Urte, Martit Sade on stage, engineer, consultant Simo Imolets, contractor Kokon Life, Kuum and Külm, who were the clients.
Inimese hinge lappergust tean mina tunnistada, enda jalgade paterdusse oskan ma takerduda. Mõttemulkude paterdust harva saan vaigistada, argipäevade askeldustesse võin eksida ära. Otsimise äär ja otsatust võtnud olen leierdada, ise oma nõrkust ja torsakust tuleb minul kannatada. Selle maailma saladustesse võin eksida ära. tunnada olemise kergust ja kergitust, saan ära tunda ja näha argipäevade üllatustesse, võin armuda täna. La 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 la, la la la, la 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 la, la la la, la 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 la, la 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 la. La 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 kaks kõverat puud juurtel kikudes, teineteisele alati truud. Kaks kõverat puud öö saabudes, kõrvuti kõrgudes neelavad huud. Kehtib püsida koos. Taas päev pääseb lahti, kui olla meil mahti, on kõvasti koos. Pisikest suud, naeru valatud, kui ka alatu on tuul. Kaks pisikest suud, läbi laulude üksteise kaugusel, just nagu puud. Kehtib püsida koos. Taas päev pääseb lahti, kui olla meil mahti, on kõvasti koos. Kõvasti koos. Kõvasti koos. Kõvasti koos. Kõvasti koos. Aitäh!
Aitäh, Mari Jürjens.
Thank you, Mari Jürjens. So we have another thank you. We'd like to thank someone who has, throughout the years, been the heart and soul of our wooden cluster, a friend, a rock, a generator of ideas, always there to help. He never keeps any of the problems, he just delegates. Who is it? What do you think? Erik, Konse. There's a microphone coming your way. Erik, we'd like to thank you for everything that we have experienced here today. I've got some notes, but I'd like to thank you. So what do you do when you clear your house, your children are away, the house is empty? You think, what's the point of it all? Why do we do this? Why do we bother? And then I thought that, if I was Shakespeare, then if Hamlet hadn't been a prince, but he'd been a carpenter, to be or not to be wood is the question. Whether to bear the soil, everything, or enter the sea of trouble and end it all, to build, to dream, no more. Because when using wood, the dreams can come. If you give up this mortal coil, because who would bear the problems of the carpenter if you had the tools that you have in your box? To build is accepting the unknowing and creating. So now I've lost my words. I'm again looking at my notes. And the fear to fail, keep us away from handicrafts. So we keep trying to build our life piece by piece, knowing that each bit has the essence of us. Thank you.
Imeilus sissejuhatus.
Thank you for this introduction. So the crème de la crème, the Grand Prix, the best wooden building of the year, the one who the laurel wreath is awarded to. So the best wooden building of the year nominees are the Dirhami Nature Resort, Rae Gymnasium, and the Thule Sports Building. The Grand Prix is awarded to those who get 2 tickets worth 4,000 euros for a study trip or conference. And the award will be presented by the Minister of Infrastructure, Vladimir Svet, and the head of the Department of the Living Environment of the Ministry of Climate, Kaja Pae. Ladies and gentlemen, friends of wood architecture, we have heard great presentations. We've learned that wood is a sensible construction material, it's environmentally friendly, it's good for our economy regionally, and it seems that also biophilia hypothesis has become something that wood is pleasant, it supports our health. And as wood is a sensible building material, then it's also in our national strategy of procurements. So our strategy says that new buildings, if possible, should be built of wood, if it's sensible. So this is the least that the state can do in order to promote wooden architecture. But speaking of sensibility, the material doesn't just have strict functions, but it also embodies culture. Over the last 10 years, it's been trendy to talk about all sorts of sort of innovative materials, but wood as a smart material is also something that we'd like to mention, that it has a lot of potential, and quite a lot of potential, because characteristics of wood are different. The isotropic bits, but it also has a good fingerprint, so dendrochronologically we can assess when the tree was planted, when it was cut, so we can set the dates. And we can learn when was this house built, if we don't know exactly. Or in Estonia, we have actually been reusing materials, so this also gives us information about how long the material has been in circulation for. So maybe this is not the first time it fulfills the purpose of a beam or a column. So this puts a time frame, and we can also talk about the cultural aspect. Researchers discovered that the life cycles of trees tell us about the supernova explosions, the carbon that it has embodied. So wood carries the echo of the universe. So if we use wood, we touch wood, we polish this echo out of the wood. I'd like to ask you to think whether wood still has a lot more to offer that we don't think of. So we play with wood as a material, and we look for opportunities to use it. I'd also like to thank the Estonian Wood and Forest Industries Association, who has promoted this whole domain. And this is the 22nd time that we have been handing out this award on behalf of the Ministry of Climate. Thank you, and I congratulate all the winners, engineers and architects.
Dear fans of Estonian wood and friends, before I am going to read out who, for what, receives the title of the best wooden structure of 2024, I like to share a thought with you. It's an expectation and it's a hope. I call upon you. It's about a building which has been mentioned today already. It is located not very far away from here. It's a short distance, a walk, and it's a sauna, Logi sauna. And I hope that if up to now you haven't been very sure whether it's worth a visit, then hopefully a few minutes ago you were convinced that this is definitely something that needs to be visited and is worth a look. And I'd like to give an applause to the authors of this idea, and not just the idea, but who have also implemented it. And these are the people who keep this tradition alive in the community, the sauna tradition. So, Logi Sauna, be sure you visit it during this winter. I've been there. I know what I recommend, so it's nice and hot in there. And now this expectation of mine. Very often, in order to change or shape the market, in order to encourage the private sector to be more bold, to want to invest more in something, the public sector has to show the way, take the risk upon itself. And I'm very happy to say that just like today, but also during the previous years and hopefully also during the coming years, there are quite many buildings which are projects started by public procurement, state, and the Ministry of Climate has initiated the construction of the Nature House, the future home of the Ministry of Climate. And I hope that that building, it's not ready yet, but I am quite sure that when it will be completed, it will be among of the nominees that particular year. A couple of weeks ago, we also launched the biggest funding project of the improvement of residential space, 185 million euros coming from European structural funds. And this means that the housing associations hopefully also will have something to boast with, something that would be also a nominee during these ceremonies like we have today. So wood is a superb material, not to build something from a scratch, but also a material that is ideal to be used for renovation, for refurbishment, for improving something existing already. I probably can't delay the intrigue, or actually that big news now that everybody is waiting to hear. And let me then announce the winner of the main winner of the best project of 2024, where wood has been used both in the structure, the main structure, the interior design, and also the exterior. And the cross-usage of wood in different functions is revealed in the best possible way in that project. The wooden structure of the year, Rae Secondary School. Raivo Kotov, Lembik Raukste, Margit Taube, and interior designers Raili Palling, Kaida Taidam, Koko Architects, Tommi Arula, Sisi So Oskar Tuvik, Make Space, Meelis Land, Novacon, the constructor, Merko Ehitus, the client, State Real Estate.
Palju õnne!
Congratulations.
Väga hea mikrofon, lähened ja...
Very good microphone, automatically coming to your height. What can I say? Thank you to everybody, the jury, the contractor, architects, designers. I'd like to underline the fact that the Rae School and Tuule Sport Hall, they complement each other. One wouldn't be there without the other. And they are meant to function together. And I think that it's superb that both of them were the receivers of a prize. Thank you.
Auhinna võitjatele veel kord meelde tuleb.
Let me remind everybody, all prize winners, please stay in the hall for the photo.
Nii on otsa saanud täna.
And having said that, the festive part, the gala part of our conference is over. And now it is the reception where you can discuss about the things you heard today, talk to each other, exchange your ideas. Thank you for all the information we heard today. Thanks to the organizers, and also thank the Association of Estonian Wood and Forest for supporting our event. And it is high time to go to the next room for some refreshments. And refreshments shared with friends, what can be better. Thank you. And now all nominees, please, would you please come up to the stage for the picture?
Aitäh!